Digital twins of daily farms with AI. Chief Digital Officer, centering e-commerce solutions,
Hello.
B2B, B2C marketplace, situated in Austin, Texas.
How are you doing?
Lender to IVCA Ventures, a VC fund, and it's a Series A funded
கால்
startup.
பண்றேன் அறியல
Chief Mentor, Industry
எப்போ
Solutions,
முடியும்னு தெரியல.
Techno NGR Institute of Technology.
Hello.
Advisor, Beyond Reality California, and All Asia Solutions, transforming skills and education with AI and XR. Now, let's see what he has for us.
Good morning from Sydney, in Australia. I'm thrilled to be talking with you, my dear students and faculty, the brightest minds who are eager to shape the future. I wish I was there in person to exchange energies in your university, and I look forward to visiting you when I visit India next time. Your conference leader asked me to share my perspective on data science in industry. And the three specific questions. Why so much of buzz about data science today? As data science has been around, at least since the advent of computers 70 years ago, or even before, manually. The second point was that which are the industry sectors where data science is applied and in what kind of use cases. And the third is if I could share some perspectives on the current work I am doing in the field of data science. So yes, I tend to agree that data science has been around since time immemorial. People have been using data to make all kinds of decisions. But why so much of focus now? Now I'll talk about that. And I'll also talk about why, what, how, who. About this $200 billion industry. Now that should wake you up. Today, that industry at $200 billion is growing 25% year on year. So those of you who are a bit relaxed, wake up. Now, the 200 billion translates to 1 lakh crore. And we will talk a little bit about that too. But to emphasize why now, let me ask you a question. Say your dad received a letter after he graduated for an interview at certain address and sent it. What steps you think he would have taken? Would have called a friend or an uncle expert on Delhi or called the office to know exactly how to get there. Maybe he may have asked somebody to even map it out. Which bus to take, how much walk he will have to do at the end of the bus stop, etc., etc. And he will have significant stress on that point. And now, to talk about today, if you had the same talent or same opportunity today, what would you do? I know you know. You simply like that it is on your mobile phone, and it'll tell you bus to take, train to take, how much time it takes to do the last mile walking, and even you would make recommendations. Say take Uber or take this bus number such and such. And without any stress, you're on your way. And along the way, supposing you're driving, it will even reroute you because of some traffic jams or accident, etc. And you are again on your rerouted way. I mean, no hassle. Sounds so simple, isn't it? But how? And that's what I will tell you is the magic of data science. And when I say magic of data science, deceptively simple it may sound, but there are 3 fundamental steps. And that's the essence of data science. And let me break it down for you. What are those 3? A, the The first step is the data collection. Google collects massive amounts of data from all sources, from satellite, from the street mapping in conjunction or in collaboration with various government departments, from various sensors and devices guided related to traffic, etc. And even from your phone in terms of what is starting address and where you want to go. And all that data is collected. Then in step 2 is analyzing. Analyze using massive size computers, powerful computers, and ever growing powerful chips like the NVIDIA GPU. And with using the powerful computers to analyze this, and then the third step, which is the recommendation. So the data collection, the data analysis, and the final step is data recommendations, and then the applying very advanced algorithms, AI algorithms of today. It makes recommendations with the bus numbers you take, how much time it will take, which route to take, which new route to take in case of accidents or traffic jam, etc. And that what makes today's scenario, particularly the application of data science, is valuable. And that, in a sense, is the fundamental reason behind data science. You have to say that the more and more it is advising you or it is making recommendations for you to make the decision, what I would call it a data-driven decision is what getting recognized is the value creator and a key driver for all that work that we talk about. So how would you simply say a simple word? Collecting and processing the data from various sources, all kinds of sources, massive sources from sensors, social media, and the like. Then analyzing these large data sets quickly and efficiently in time for you to take decisions. And of course, application of AI. And more so in the last 2 years. Value of AI, particularly with 2022 event when OpenAI opened up to the world with the generative AI tool, it is going leaps and bounds. And that's something, call it data science doing it or call it enabling it or enabling the democratization of technology. Think about a rich man in his big Mercedes and a poor small courier boy on a tiny little bike, both are using the same Google Map. And that's what the biggest value from social creation has been delivering the democratization of technology. So, should we say that because of data science, or thanks to data science, today our lives are simpler, we live stress-free, we live longer, our resources are utilized more efficiently, and as I mentioned, democratization technology. Now we talk about transportation as an industry. But if that is, data science is applied or is applicable to all industries. And when I say all industries, some industries, the market spend is not more than the others, and more applications are being already in use, while some may be a little behind, but more people are working. So when I say, if I was to look at specific industry and use cases, I would say the one right now or so far has been led by banking and finance industry, and the kind of use cases you can think of personalized investment strategies, fraud detection, risk management. And healthcare is something which has used it and spent a lot. So in industry we talk a lot about dollars, it has spent, but a lot more is happening as we see, particularly in the areas of early disease detection, such as cancers, fertilize the treatment plan, vaccine development as we saw during the COVID, PDR vaccine development, which used to take years, but it got developed very fast. If you look at manufacturing areas like predictive maintenance so that your machines don't break down, you're driving a car and you don't want it to break down on the middle of a bridge. Also improving the overall process efficiency in manufacturing. And so many different things, so many different areas in logistics, it is getting so that you get your Swiggy delivery just in 30 minutes. So that is just that it is a large industry and it is growing at 25% year on year. By the $200 billion industry already has become annually. And in terms of number of people, there are some 15 lakh people already working globally as their scientists. And again, that number is growing. So opportunity is big for you. But of course, every company, every IT company is working in it, but some of the leaders getting recognized who have been more active in this area are Microsoft, Google, IBM, SAS, SAS company. As I mentioned earlier, everyone, not just IT company, but every single industry motivated because it enables them to make a country one. Now, for the third point, to share some of the work I have been doing. So, if I start talking data science and myself, my first project, but I'm not going to talk about that, it was way back in 1975, and I was a student working on the medical diagnosis. The size of the computer, if I talk about it, you will fall off the chair. So the total RAM memory was only 16 kilobytes, and I had to accommodate 200 diseases and 200 films. But never mind, the concept was still the same. Looking with the main expert at that time was one doctor in our local hospital in Pilani, where I was studying, and we were able to diagnose based on the signs and symptoms potentially 3 or 4 potential disease that patient has, and then make some recommendations on doing some confirmatory tests such as blood tests, stool tests, etc. Before the doctor can make a response, she can make a recommendation on specific or 1 or 2 identified disease. But as I mentioned, that was 50 years ago. And I had a number of different opportunities to apply. Still in 1985, when I joined IBM and become a data architect. But I'm going to talk about, just to highlight its application is one of the strangest thing you can think of. I'm currently co-founder of dairy farming industry in Australia. Again, the goal here is to produce more milk for the growing world population and also to reduce methane. And as many of you know, methane that cows burn out is 25 times more percentage warming than carbon dioxide emissions. And one of the driver or the customer, if I should say, is the dairy farmer. Poor guy or a family who has been doing this business for decades, but now because of the rising costs and not much increase in the milk, they're closing down. In fact, one dairy farm closes in Australia every day, about 10 a day in USA. And the primary reason, as I mentioned, is low profitability and very laborious job. But let me give you a couple of minutes talk on what is that. Picture a typical Australian dairy farm. It's about 2 square kilometers farm, divide into about 40 small trees called paddocks. And each paddock has grass growing at different lengths, and each paddock is sufficient for his 300 cows for a day. And of course, he rotates those paddocks. Now, one of the biggest stressful decision he has to make is which paddock he should send his cows, 300 cows, to graze today. And he has to walk, and he has to see, and he has to estimate, and he has to guesstimate. And he comes with that recommendation, that decision. If he gets it right, he's smiling, because there is a moment well produced, but he often goes wrong. And his milk that day declines. So that's what the current state of his milk on a daily basis, if you look at a particular month and week. So how are we helping this dairy farm? What we are doing is we are collecting data about the cows as well as paddocks. Every data, for example, for cows, like what's the genomics, what's its milk giving capacity, what's its feeding requirements, what are the diseases it has had, and it's having. We even put some variables which can I say almost like Fitbit. And for each cow we create what is called digital twin. And likewise we create digital twin with all this data for the paddock, quantity, quality. And to do that, we collect data from cameras like drones, the IoT devices like wearables, and laboratory tests and more. We then analyze this data with digital twin to give, using AI algorithm, to give recommendations for optimizing the feed, improve the health and welfare of the cow, right time to do insemination for expert, and the early diseases which are determined, and right kind of intervention if it is required time. So we kind of make or help farmer make data-driven decisions versus the decisions he and his family has been making purely based on experience or guess. And in essence, we are helping dairy farming industry to be more profitable, less laborious, and sustainable. Now, I won't go in too much into the methane, but yes, now the energy which or the food which gets converted into this bulk to right intervention, some of that can be reduced. And in fact, that energy of the food can be converted, energy from the food can be converted into milk. So, reduce global warming on one side, but at the same time, efficiency of the system in order to increase milk cost. So I can go on and talk about various other initiatives which are taking place in different industry sectors. But I guess because I realize that industry side is big, opportunity is big, your chance to apply all that is also very big. So at this point, I'll try to sum up. I would say that data science is driving the future. The beauty of data science lies in its endless whether planning, climate change, education, entertainment, you name any industry sector, data science holds the key to solve the complex problems of the future and drive innovation. So my closing remarks and advice to you, my dear students and faculty, you're stepping into the world where data is new oil and AI is the engine that powers the program. Whether you become data scientists or entrepreneurs or leaders in other fields, understanding and leveraging data science will be crucial to your success. Embrace opportunities, be curious, and never stop learning. The future is yours to shape. Thank you.
sir, for your insights and your presentation. So I would like to guys to hold on as we'll soon start the next presentation. Thank you.
भाई भैया अपने लैपटॉप से कर लीजिए। जितना इंटरनेट करेंगे अच्छा होता है उसमें करेंगे। मैं स्क्रीन प्रेजेंट हुई ना मेरी। हम लोग लिए भी फ्री है। और आपको सजेशन दूर रह के बात कर दिएगा का तो उससे वॉइस भी आएगी उसको कनेक्टेड वो भी होगा तो आप बोलेंगे। दूर बैठ जाइएगा क्योंकि माइक भी टकराएंगे। वे जब आप बोलोगे मैं लैपटॉप भी मीटिंग में कनेक्ट है तो पिच पिच की आवाज़ आती है। हाँ दूर बैठना है। आप थोड़ा एंड में बैठ जाइए आराम से। नहीं प्रॉब्लम मीटिंग में है ना दोनों लोग तो माइक की किच पिच आएगी फिर इस पर आवाज़ें आएंगी सबकी दोनों बातें लैपटॉप में भी। बैठे उधर बैठे। तो ये वाला कर लीजिए। आ जाइए बस, बोलने की दिक्कत नहीं। किस अकाउंट की आवाज ना। अच्छा बस आप तो बस क्वेश्चन पूछे बस। ये रिकॉर्ड करना है, उसमें दिखा दीजिए आपका इंटेंशन। रिकॉर्ड करना है। नहीं हुआ भाई, सेवा नहीं होता। फ्रीज नहीं हो रहा। करना है। एक मिनट।
Hello, good morning. Good morning. Good morning. Good morning.
भाई इसको बार बार फ्रीज करने की जरूरत नहीं है, वो ऐसे चलता रहेगा, ठीक है।
नहीं, फ्रीज इसलिए क्या था क्योंकि ऊपर पेपर दिखाना था। अब
ठीक
ये
ठीक ठीक है।
Yes, yes, we can hear you.
ये इको क्यों आ रहा?
बंद कर दो।
ये
ही बंद है।
अरे तुम्हारा कर दिया, म्यूट
ये
कर
आता
दिया।
है कि उससे आवाज नहीं आएगी
1 मिनट, म्यूट करो, तुम इधर से कर दिया, फिर क्यों आ रहा है आवाज? अब नहीं आएगा, म्यूट रहने देना। कुछ
So,
बोलो
good
तुम,
morning. Today we have
मान लो तुम्हें कुछ
Mr.
बोलना है ना,
Jashwant
उसके
Chana
बाद फिर
with
अनम्यूट कर देना,
us.
इको नहीं आएगा।
Mr. Jashwant is a skilled machine learning software engineer currently working at Google with a passion for applied machine learning and deep learning. With 5+ years of relevant experience, he has worked for leading companies such as General Motors and Magna International in the past. As an autonomous driving software engineer at General Motors, Mr. Jaishwant was responsible for developing and testing advanced driver assistance features such as lane keeping assist and collision mitigation braking. At Magna International, he benchmarked in-house computer vision chips against mobile eye Q3 and developed a closed-loop test system for front camera modules. Mr. Cheshman holds a Master of Science (MS), a degree in electrical engineering from the University of Texas at Arlington, and a Bachelor's of Technology (BTech) degree in electrical engineering at University of Pondicherry. He also completed the self-driving car engineering nano degree program from Udacity. Mr. Jaishwant's technical experience includes software engineering, machine learning, deep learning, and computer vision. With his strong deep learning skills and attention to detail, he is adept to developing innovative solutions to complex challenges. Mr. Jaishwant is committed to continuously leading and enjoying challenges up to date with the latest trends and technologies in his field. He is a valuable asset to any team and is always willing to share his knowledge and expertise to help others grow and succeed, as he is today. So
Mute है।
now the stage is all yours, sir.
Mute
We
है।
are pleasure to have you here.
Sir, we can start, sir.
Can we start now?
Yes, sir.
Sir, am I audible there?
What's up?
So you can start, sir. No issue. The session is live on YouTube. I welcome you.
Sure. Yeah, I can go ahead. So, hi. Yeah. So my name is Tishwan. So I work as a senior machine learning engineer. I work in Google Gemini team, working on advanced data analysis features on Gemini. It allows user to upload data as queries. Analysis queries, not for giving in-depth insights from the data, etc. So today I'm gonna talk about what is involved in developing Gen AI feature. So before we go into the details, let's have a quick recap on the evolution of language models. So over the years, over the past few decade, the language models went through multiple changes. So initially, we used to have a very simple word of backup words models and word-to-vec models, and then we have CNNs and RNNs, recurrent neural networks. RNNs were there for quite some time. There were multiple advancements come on top of them. Finally, we have the transformer model, which enabled all the recent innovations with large language models and the reason for all the ChatGPT and Gemini models you are seeing now. So back of words, like initially, if you have input text, we used to take the input text and use simple features like frequency of the different words or TF's idea of features, like it's very similar to like frequency. And then we used to use a linear classifier to perform like sentiment analysis or do some kind of classification of this text. So we used to not worry about the ordering of the words and things like that, just frequency of different words in this input text. And then we have word-to-vec models, which are trained to convert a particular word into a vector of embeddings, basically a vector of floating point numbers. And this vector, this embeddings used to capture the semantic, the meaning of the word. So here in the example, you can see if you take the embeddings, the word king, and you subtract the embeddings of word man, and then add the embeddings for the word woman, you will end up with an embedding which is very close to the embedding of queen. So two embeddings. So if two words have a very similar semantic, very similar meaning, then the percent distance between those two embeddings would be very small. So basically, the embeddings capture the semantics of the words.
Windows speed duplicate
This embeddings were then inputted to a linear classifier to do any classification we want. So given input text, we take in embeddings of each word and we probably sum it up together and then apply a linear classifier on top of it. So then comes the recurrent neural networks. So recurrent neural networks, so they look at each word at a time in a sequential manner. So first they look at all the words in the input text, and they start from the last word. They start generating the next word. So they look at a word, and they basically generate the next word, and the next word will be the input for the same network. the next step, and then it generates the next word, and it keeps going. So and then at each stage, when the model visits a particular word, it can also access information that from the hidden state of the previous step. So that's how it gets information from whatever happened so far. So there's this information pathway for all the information to flow from the previous words. You can see that. So this is kind of a constrained pathway, because this path, so all the information from the previous words has to flow through this for this network to predict what would be the next text. So this is a constrained pathway, and because of this, recurrent neural networks are not very good at predicting the next word. And then there were some advancements done on top of it to make this pathway better, but again, these advancements were minor. So with transformers, so the thing is, we have this new attention block. So this is the transformer architecture. This is from the paper. Attention is all you need. So if you see here, there is this encoder and decoder. Encoder is basically, we take all the input text which contains user query and other things, and then we basically feed it to the encoder. The decoder, this is where we generate one token or word. You can think of token as a word. We generate one token at a time, and then the token is fed back. And then the model generates the next token. That's decoder phase. Right now, we don't use most of the industry doesn't use encoder decoder architecture. They use decoder only architecture. So this is the decoder only architecture. So at the core of the transformer model is this attention block. We go into details in the later slide. So the attention block, what it does is it allows every word to access any word that comes before it. So this is what is way different from what we had before with recurrent networks, where at any given point, the only information that it can access is through this information pipeline, which there's only one way of accessing information from all the words before. But with transformers, at any given step, it can access every single word or token before the current word. So before going into the details, the attention block, for each token, we compute three vectors: query, key, value. We take the query of this particular token, and then we multiply with the keys of all the tokens that are before the current token. And when we multiply, we get the attention. So this is the attention is how much the current token wants to attend to any previous token. So it has access to all the previous tokens, and this attention tells us how much it wants to attend to the previous tokens. And then the last value vector. So we basically take a weighted sum of all the value vectors, and the weight is the attention. So that weighted sum is the output of the attention layer. So in summary, long story short, attention allows a particular token to look at any other tokens directly, to access any token directly, while RNNs, it can only access through this information bottleneck. So it has to get all the information from all the tokens before through this one information bottleneck. So that's the difference between RNNs and with this new attention and transformers. That's what enabled all the innovation, all the great, the high quality you're seeing with GenAI. So here, there's a demonstration of how a word or a token can attend to any other token in the input text so far. So if you see the thickness of the line you see here, basically showing how the attention is it higher attention or lower attention, the weight of the attention. And we have multiple attention layers, making it multi-head attention. And here we call it masked multi-head attention, because we only allow allows a given token to look at the tokens that occurred before, not after. So the reason we do that, so that's why we call it decoder only architecture. The few advantages for doing that, I'll discuss that later. So at the core of Gen AI feature development, we have prompting. So prompting is nothing but input to the model. So prompting can include instructions to the model. It can include user query, the query that user typed to the model. It can include previous conversation that user had with the model. And it can also have few short examples. In the next slides, we look at some prompting techniques that are popular. So in zero shot prompting, we basically don't show any examples of question and answers. We just basically provide instructions to the model. We just say the model, you need to respond this way. So here is a query, you need to respond to this query in this particular way. In few shot, you basically provide bunch of question answers to the similar question answers to the model, so that and then you actually give the correct query, and then the model will basically look at this few examples and then basically tries to answer, mimic the same style, mimic the same technique that we used in the answer in the examples. And then the other popular techniques are chain of thought. And then there's also tree of thought that is currently being explored. For chain of thought, so chain of thought is really needed for answering complicated queries. So usually when there's a complicated query, like in this case, what is the percentage difference between India's and China's population? Now in this query, even humans cannot answer this query directly. Like they have to know first of all, they have to know the information of India's and China's population. And then they take the population and they have to do some math on percentage difference. They probably will verify the calculation, and then the final answer would be here is the percentage difference. So this needs multiple steps of thought to answer this query. So now usually even similar to humans, even LLMs to solve any query, any question, there's like two ways of the system one thinking and system two thinking. For straightforward queries, we usually use system one thinking, which is quick, instinctive. Like if you're asked 2 + 2, we answer quickly 4 is 4. This is coming from system one thinking. We don't really think in steps, or we don't reason. So for system two, for complicated queries, we use system two, where we think slowly, we put effort, we think in steps, and then we answer the question. So the chain of thought is basically helping the model to use system two to behave in the way system two does, not like system one does. Usually LLMs just behave always like system one. You ask a question, it generates the answer. It knows that whether it's correct or wrong, it just generates the answer. So it usually always behaves like system one. So, but for complicated queries, you want the model to behave like system two. So what you basically prompt the model, the two in this case, in the first here I'm showing how we are prompting the model with few short examples. Here I'm showing a query. It's a single shot, so one example, I'm showing a query and then an answer. In the answer, instead of directly giving the answer, like the answer is 11, I'm giving the answer contains thought steps, like so Roger started with 5 balls and then something happened. So basically there's a detailed steps involved in getting to the final answer. And now when we have a new query, the model gets the answer right. So making the model think in steps, or solve the problem in steps, and have a thought for every step would improve the model quality by a lot. So in the other case, like a simple prefix, like let's think step by step, would improve the model quality, even without giving any few short examples. Just this small piece of text, let's think step by step, would improve the model quality by a lot. Now, so prompting is how So you take already trained model, an instruction tuned model, so the model already knows how to answer queries. You take that model and you prompt it to behave in the way you want. Now, so if the prompting is not enough, then you have to train the model or like fine tune the model. Now coming to so now in the next slides, we go over model training pipeline, like how we actually train this model. So first, I mean, if we start from scratch, this is like when we start from scratch, when we don't have anything with us, like there's no base model. So first we do pre-training. That's when we actually train a base model. That's when we basically train the model on like huge corpus of text from internet, and we train the model for probably weeks, days, like weeks, and then the model, and then that would be the base model. At this point, the model doesn't know how to answer query. It knows how to predict next token given an input text. And then we have supervised fine tuning where we fine tune the model to answer queries or behave the way you want the feature. Like when you're developing a particular feature, the supervised fine tuning is where you teach the model how to answer the way you want. And then RLHF is where you perform, you kind of squeeze more performance out of the model by teaching the model, by rewarding the model when it generates a response you want, and penalizing it when it generates something that you don't want. So when we train this model, so we take the raw text. So you can't feed a text as an input to a neural network. So you convert this text into numbers. So for that, we first tokenize the input text. Tokenization is basically a way to the tokenization. What it does is it compresses the vocabulary. Without tokenization, what happens is you'll have a huge vocabulary with tokens. You will compress the vocabulary. Like what it does is, so for there are multiple tokenization algorithms. So one of the popular one is byte pair algorithm. What it does is it kind of, you can think of it like it takes most frequent character pairs in the input text corpus, in the training corpus, and then replaces with a new character, and then it does it again and again. So we're taking the most frequent character pairs and then replacing with a new character. We do this again, and then we iterate on this until we reach a point where we reach the vocabulary size that we want. So a token can be a single character, it can be a group of characters, it can be a group of words. So we end up with this token. So in this case, you can see THE is one token. Under space G is a token, PT is a token, space family is a token. The reason why we get this vague structure is because of this grouping you do. The algorithm efficiently groups very frequent characters, like very frequently occurring characters. It does it at byte level. So it groups frequently occurring characters together and then creates a token out of it, and then it keeps doing that. So now each token becomes an integer. That's how we convert the raw text into a bunch of numbers that we can input to the code. So now for data prep, we take the input text. We probably take a batch of them. So the batch size can vary. It's usually a given number. So we take a batch of them, and then we create a matrix out of it. Each row represents a particular input example. So here is an input text. Like row one, here is an example document one showing some tokens. That's the first text. Then the equivalent tokenized numbers, you can see it here in the table. And row two is another text, and you can see in the second row in the table the equivalent token for that. Now, So here's the backside is true. We are inputting like two inputs to the model, like we are grouping like two inputs to the model. And then the horizontally, you can see all the tokens involved in each example. Now, when we train the model, what we are teaching the model is just next token prediction. So here are the tokens that we have so far. Now predict the next token. Now, in this case, everything you see in yellow is what happened so far. And the model is trying to predict what's going to happen in the blue, for the blue cell, like what token will come next. And the actual token is 500. We know the actual target. And the model is predicting some target. And then we do a cross entropy and then backplot. We teach the model to, okay, so you predicted it right, you predicted it wrong, teach the model, you train you update the weights. And that's how you teach the model to predict the next token. So once you pre-train the model, you train the model this way on like huge corpus of data. Now the model, can understand tokens, can understand grammar, English, semantics, and all this stuff. And at this stage, the model looks like a document generator. So if you give it a query, it will not answer it. It will probably generate more queries. Or you start with something, you can think like package. If you just say package, it will probably write a Java code. So it acts like a document generator. It will not act like an assistant. It will not answer the query. It will probably just create more queries and just fills it up. Now the next step is making the model to answer the query. So this process is called supervised fine tuning or something. It can also be called an instruction tuning. So this is when we teach the model to answer query, to act like an system. So for this, we train the model with specifically handwritten examples of data. Like here's a user query and here is the answer. And we train the model with this data to teach the model how to answer user query. These are the model learns. Okay, for a given query, so I need to answer it, and then starts answering. Now, this is mostly handwritten initially, but when the model gets better and better, what is done is we first train the model, we first generate the answer by the model, and then we rewrite. The bunch of people will rewrite the answer to whatever the right answer you want. That's how you create more SFT data. So in a way, you get the baseline data from the model itself, and then you just rewrite and get it to the state you want to create the SFT data, and you train the model. So at this stage, the model knows how to answer a query. Right? You ask a query, the model knows it needs to answer it in a particular way. Now, the SFT is usually done, so the pre-training is done probably in months. It takes a lot of data, a lot of time to train, a lot of money and compute. So this is done usually in months, sometimes even in years. SFT for supervised fine tuning, this is done in days. So we create instruction for people to label data, like rewrite data, etc. And the people rewrite data, they create a bunch of instruction tuning, and then we train the model. Then we see the model behavior and we fix any issues with the data, and we keep doing this. And this cycle is done in days to improve the model quality. So next is RLHF. So RLHF is like teaching the model, like rewarding the model, like encouraging the model to behave, generate responses that you want, and discouraging the model to generate responses that you don't like. So in RLHF, the first step is training a reward model. A reward model basically tells whether the response is good or bad. And the way you teach the model is basically by providing the data where for a given query, you scrape multiple responses from the model. So the model, you can scrape multiple responses from the model, and the rates for a given pair of responses, the rater rates which pair is better than the, so which response is better than the other response. So the rating rates a pair of responses, saying this left is better than right or right is better than left. And then we take this comparison data, like we have a query, same query, and different responses. One side is better than the other side. We take this comparison data and we take the SFT model as a baseline. And then we do a classification. We teach the model. Now here is the response. We teach the model saying, okay, this response is better than other response. Now after training the reward model, given a user query or given a response, the reward model will give a score, like good, bad, like how good it is, how bad it is. Once we have this reward model, what we do for RLHF is we take a bunch of prompts, just user queries, and we take the SFT model, we generate the response, generate multiple responses, and then we use the reward model that we trained. So for each response, the reward model gives a score for each of the response. And now we train the SFT, like RLHF model, very similar to what we discussed before. So like next token prediction. Whenever it's predicting next token, we use this RM score, the score that this RM model gave for that response. We use that reward as a weight whenever we do the next token prediction in the cross entropy loss. And this after this RLHF, you have speech more performance out of the model. The model now knows how that is encouraged. Now we encourage the model to generate responses that we like and discourage it to generate responses that are not ideal for us, for the feature that we are developing. Now, at this stage, we have a fully trained model. Now, so as you have seen now, for training model is very computationally expensive. We need to spend time, money, compute, to train the model. So for efficient fine tuning of the model, there are multiple methods proposed. So one of the popular methods is LoRa, LoRa annotation. So usually in the feed forward network, we add a LoRa a network like this, which basically, and when we fine tune, we only train. We don't train the actual pre-trained weights. We train this additional weights that we added. These weights are of lower dimension, so they're way lower dimension compared to the original weights. So you are basically training a smaller set of weights. So it's not as computationally expensive as training the whole model. And once you train this adapter, which has less number of weights than the original network, once you trained it, you can add it back to the original network and you have the final network that is fine-tuned. So this is one way of efficiently fine-tuning the model without training the whole network again with this computation expensive. This would be probably in the order of hours. So you can train this adapter in the order of hours and then merge it with the base network. So now we came to the last part of the presentation. So let's discuss some techniques of making the model more accurate. So now, even after doing all this, the model can only answer from what it is trained on, like what it memorized from the training data, the probabilities that it learned of predicting next tokens, it can rely only in that. So to make the model more accurate, the most famous technique is RAGs, retrieval augmented generation. So this is nothing but for a given query, we retrieve the content from internet or any other database that the query that is relevant to the query, and then we append the information we retrieved along with the query. Now we have the query and all the information from internet or that is relevant to the query. Now the model can respond in a better, more accurate way. Yeah, without this, the model doesn't know what is if you ask what is the current stock price of Microsoft, it doesn't know the current stock price. It needs retrieval from it. Now the other thing, last thing I want to talk about is to use, which is what is enabling all the features you are seeing in ChatGPT and Gemini and all the other models. The tool use enables the model to use tools. So in this example, you can see, so there's a query like what is the percentage difference between India's and China's population? In this case, the model is first using a tool. It is responding saying, I want to use search tool, the population of India. There is a query to search. And we teach the model to behave like this. We teach the model to do that. So, and we take the, okay, we see this model generated this text, and we know, okay, it wants search tool, and here is a query. We go search for the query and gets, and we basically add the tool response here. Okay, Indian population so this is from Wikipedia. And the model is again saying, okay, I want to search the population of China, and we go search for it. So here search is a tool. So, and the tool response is China's population, so and so from the Wikipedia page. And the model is wants to use a calculator tool, and this is what he wants to calculate. And then we go run the calculation, and here's the answer. And now the model finally says a percentage difference between Indian population and China population, so and so. So this is how the model is using tools. And you can think of them, so this tool can also be an agent. Agent is nothing but another LLM, a model that does something different, something unique, like code generation. The model here it can be a code tool. You can say, okay, I want a code for doing something. Now the code tool itself can be an LLM. So the model gets the instruction, writes the code for doing that. So you can see how all the different tools and agents interact to fulfill a very complicated query like this. Most of the advanced features of Gen AI are all done this way. Using multiple tools, agents, they all interact with each other to get to the final answer. There are a lot of other things, like prefix caching, dynamic prompting, for safety, which all help to, solve any long tail issues that the model is facing, squeeze more quality, make the model more safe, and things like that. That concludes my presentation. Thank you, everyone. Yeah, let's stay connected.
Yes, we have a couple of questions, Jashwant. I hope you can.
Yeah, sure. Go ahead.
Yeah, just a minute. We are just connecting the speakers so that everyone can listen.
और हेडफोन है आपका स्पीकर इन्हें बोलिए
Hello.
सर से बोलिए
Am I audible?
Yeah.
किसमें है भैया वो स्पीकर में जाना है
Just a minute.
किसमें जाना है एक्सेप्ट बोलिए
Hello.
Yes.
Okay, I'll take it from here. Sorry for that. Thank you. It was one of the most fantastic session we have got from your side. And since many students are also here, so I took some questions from the student side. As there are couple of students who are working on LLM prompt injection. So what is your take on that? And how you see LLM prompt injection and the solution to that LLM prompt injection by using input sanitization and validation in order to provide defense against. So what is your take?
Prompt, that is an evolving field. There are multiple instances where prompt injection happened or genetics or even so sanitizations and other techniques were in place. I think so. It's still evolving field. I think it's not a solved problem. So any given user query, checks were done. Like if there's a link in the user query that needs to be checked,
So,
a code in the user query that needs to be checked and sandbox. So for example, user wants to run a piece of code. The code is run in a sandbox environment.
System
And then if user wants to access personal data like from Google Drive, etc., that is when that is a huge risk. So that is where most of the prompt injection attacks happen on like when the model accesses personal data from Drive, etc. And that is so that is where I think mostly through code, having tight sandboxes,
so
then
the reason I've asked this question because when we utilize many of the systems in order to bypass the online processing that LLM do takes, because most of the organization also uses LLM in order to perform any kind of analytics. So there we can inject with some malicious prompt that can bypass or do malicious things for the analysis.
yeah, definitely agree. So this problem is not solved as I said. I think I don't know the exact solution for it, but there are a lot of checks in place to catch them. But I don't think that's a comprehensive solution. Like it's not a solved problem.
And one more thing, students, because you know very well the student uses ChatGPT, Gemini for their assignment works. So they are asking that when the accuracy of the model will increase for solving mathematical problem.
I think it's actually there are tools that can actually finish the homeworks for students in their own handwriting and etc. But yeah, so Gemini is being used for all of this. I can't comment whether it's a good thing or a bad thing. It's kind of a bad thing for now, but it can, yeah, it's different perspective. It's bad thing for teachers, it's a good thing for students. Yeah.
Okay, one more question which was asked by the student on what you have said related to the multi-head attentions. So how does leveraging multiple attention heads help in detecting subtle and complex malicious intent that might not be evident in a single attention perspective?
So for malicious, I'm not sure how but the multi-head attention, each when you say multiple heads,
Yeah, the next slide.
Yeah, each head is basically looking for different aspects. So one particular head might be looking for verbs that are close to this, one or the other head is looking for something else related to it. So each head is looking for a particular thing. But in the question you're asking, like, can the heads look for? You can have the heads if you train it to probably detect malicious stuff in the input text. Probably some of the heads are probably looking for like the malicious connection between the tokens. Like when this group of tokens all come together, that is malicious. So usually each head is looking for particular features, like different kinds of features. But they're not looking for malicious content particularly. But when you train for catching the malicious stuff, it might look for kind of features.
So I'll give a use case of last week what we did. That means there was a profile which is non-technical for a student. Okay, so we injected some malicious keywords and tokens into the resume and make it as a technical resume. And then what happens? A company, let's say ABC only, because they use a software in order to identify the skills which are there in the CV, right? So ultimately they shortlisted.
Because of malicious stuff. So okay, the malicious content is basically forcing the model to shortlist always.
Yes.
Which model, but anyway, so that is surprising to me, like making the models. I mean, it's not surprising. I mean, if you can target a particular model to do that, you can't.
No, but this is another side of the model, because there are people who can do a lot of stuffs, because organization also uses AI in order to shortlist the CVs.
I agree definitely. So you can basically add. You can train the model and add bunch of tokens before and teach the model to learn those tokens, which will always generate a chain response, like always select the resume or something. So, yeah, I agree. This is a big problem. I don't have a good answer for that, like how to fix it.
No, it's okay, it's okay.
Yeah.
So thanks a lot. It was a very fruitful session from Vellore Institute of Technology, Bhopal University. I would like to thanks once again for your esteemed time. I know that it is night there at US, but certainly you have found a lot of time in order to spare that precious time to our students, scholars, faculty, and participants. And really, I am thankful to you. Thanks a lot.
Yeah, thanks a lot for the opportunity.
Thank you.
सर आगे धर्मराज सर वो आपसे रिस्पॉन्सिबिलिटी मैं फ्रीज कर दूं
इसको फ्रीज कर दो, वॉलपेपर लगा दो।
हाँ
फ्रीज कर देंगे
कर दिए ना।
ये म्यूट है कि नहीं चेक करना।
हाँ आवाज आ जाती है
Sir?
Hello, good morning.
Yes. So I would request the master of ceremony to introduce yourself. Just give me a time.
Sure.
Right, sir. So the session is live on YouTube.
You want me to pause it?
Just a minute, sir. Just a minute. Abhay.
Now, I would like you all to introduce you to Mr. Abhay Rathani. With over 20 years of IT experience serving Fortune 500 companies globally, he specializes in intelligent automation and designing complex solutions using low-code, no-code platforms. He possesses extensive hands-on experience with cutting-edge technologies such as robotic process automation, RPA, intelligent documentation processing, IDP, process mining, data fabrics, APN Copilot, AI, and ML. His focus is on driving technical transformation to automation solutions that streamline workflows, reduce costs, improve scalability, and optimize operational efficiency. He has developed expertise in implementing low-code, no-code platforms such as APN, OutSystems, UiPath, and Microsoft Power Platform. Using these platforms, he has helped clients reduce development time by 50 to 90% compared to traditional native technologies. Throughout his career, he has authored several custom smart service plugins, including an intelligent document search plugin, text replacement plugin, document format conversion plugin, and document comparison plugin. These plugins have enhanced functionality and adaptability for the PPL platform. And Now, he has the privilege of serving as a judge for the world's largest innovation event, the Smart India Hackathon in 2017, where he evaluated groundbreaking ideas, assessed their feasibility and scalability, collaborated with fellow judges and mentored participants on technical implementations. He continued his role in subsequent years, participating as a judge again in 2018, 2019, and 2024. So now, let's give a huge round of applause for Sir, and Sir, the stage is yours.
So you can start, sir. Yes, sir.
Good morning, everyone.
Good morning, sir.
Good morning, distinguished guests, researcher, industry experts, and enthusiastic participants. It is my honor and privilege to address this esteemed gathering. This conference is not merely an event, it is a conference of ideas, innovation, and inspiration. It provides an invaluable platform for researcher practitioner and thought leaders to explore the limitless possibilities in the realm of data, computation, and communication. Today, I am going to talk on opportunities and challenges in the area of data computation and communication, and the role of AI and emerging technologies, and a vision for the future. So we are living in a time where data is not just a byproduct, but it is really a currency in the digital age. Every action we take today, whether it's sending a message or making a purchase or taking a step, it generates data. So according to the recent studies, by 2025, the global data sphere is projected to grow by 175 gigabytes, which is huge. But this data is in raw form holds no significant value. It is the computation and communication layer that transforms this raw material into actionable insights and enable connectivity that drives progress. Communication, on the other hand, has transcended the boundaries of human interaction. Machines now communicate with each other. They are forming backbone of the Internet of Things. From autonomous vehicles to smart homes, seamless communication between devices, system that has become essential today. So this conference comes at a very critical juncture where data computation and communication are reshaping industries, governments, and society. The discussion we are having here are not just academic. They are actually deeply practical and transformative. So how do we handle the explosion of data type efficiently? What role will AI and machine learning will play in unlocking new possibilities? How like the communication network like 5G and soon like 6G ensure how high-speed data and secure interactions? So these are not just technical questions. They have the potential to influence our lives. The answer we explore will determine how we innovate in healthcare, education, finance, and many more fields. While the opportunity in data techniques and computation and communication are immense, they come with equally significant challenge and demand our collective responsibility. One of the foremost challenges is like data security and privacy. As the volume of data grows exponentially, so there's the responsibility to protect it. Data breaches and unauthorized surveillance and misuse of personal information are some of the grave concerns of today. It is critical that as we innovate, we embed ethics into the core of our solutions, ensuring that the privacy and security are non-negotiable foundation of our work. Another challenge here is like a digital divide. So communication technologies like 5G have the potential to connect billions of people, yet like million are remain without basic internet service. This divide is not just about technology, it is about opportunity, education, and access to essential services. So we must ensure that our innovations are inclusive, reaching underserved and underprivileged communities. Sustainability is another concern. The computational power required to process a vast amount of data, it consumes immense energy. Data centers alone accounts for roughly 1% of world's total energy consumption. This places a significant burden on our planet. So urging us to design a greener algorithm and system. Innovation must go hand in hand with environmental stewardship so we can create solutions that are powerful and sustainable. Another challenge we face is in fostering interdisciplinary collaboration. The most groundbreaking advancement will not emerge in isolation, but through partnership that transcends traditional boundaries. Physics, biology, sociology, and other fields hold untapped potential to enrich our understanding and approach. So the conferences like ICDC are crucial for establishing these connections and bridging the gap between these disciplines. Talking about artificial intelligence. So AI is undeniably a cornerstone in both data computation and communication. Advanced AI, like advanced AI models demonstrate how computational power can transform industries from analyzing this vast data set in real time to optimizing the communication network and enabling predictive maintenance for infrastructure. Beyond AI, other emerging technologies such as blockchain, quantum computing, edge computing, these techniques are poised for redefine how we approach these fields. Quantum computing, for instance, promises to solve problems that are currently computationally challenging, while blockchain offers a new paradigm for secure and decentralized communication. The convergence of these technologies open a future of full possibilities. Imagine a world where data computation enables predictive healthcare, reducing the impact of disease before that manifests. Envision communication network so seamless that they enable immersive experience like virtual reality classroom for students in remote areas. This is not science fiction, it is future we are collectively building. But for this vision to materialize, it will require our unwavering commitment to pushing the boundaries of what is possible. Before I conclude, I want to extend my heartfelt thanks to organizers of ICDC 2024 for creating this vibrant platform. Their effort reminds us of importance of coming together to share knowledge, challenge ideas, and inspire each other. To all the participants, you are catalysts of the progress. Whether you are representing a research paper, attending a session, or doing a networking during the practice, remember that your contributions are essential to shaping the future of the data computation and communication. In closing, let me leave you with this thought. The greatest innovation in history have come not just from breakthrough technologies, but from a commitment to using the technology for the betterment of humanity. As we engage in the discussion debate over the course of this conference, let us keep this high purpose in mind. Thank you, and I wish you all a very productive and inspiring discussions. Thank you very much.
Thank you, Dr. Abhay sir. It was a very fruitful insight you have given on the conference as well as many more important things related to technology. We appreciate your time and we would like to thanks from VIT Bhopal University as well as an organizing committee. I would really like to thanks and appreciate your time. Thanks a lot, sir.
Thank you, everyone.
Good morning. हाँ सर, आप आ जाइए इधर अपना ऑडिटोरियम में, मैं करवाता हूँ, ठीक है? ओके। देवराजू सर, So there is one participant offline, so we have to take his presentation. What we can do is Dharmaraj sir will join here. So could you please forward that participant to Cyber Lab? Saravanan sir will be there. Online evaluator are also there, and he can sync in anywhere else for the presentation.
Offline presentation. This participant.
No, only one participant. He will come now. You sit here only. The moment he will come, you just guide him to go to Cyber Lab.
Okay, okay, nice. You need to give kit also, no?
Yeah. It we can give later.
Yeah. Once he come, now you tell us.
So please come. Please to कर.
माउस क्या म्यूट हुए?
Mute कैसे होगा?
क्या म्यूट?
ये नहीं नहीं अच्छा यहाँ से म्यूट होगा क्या?
नहीं, मन से ही होगा। म्यूट करना है तो क्या हो गया सर? ये हो जाएगा म्यूट ऑडियो।
Ready? Now, please go ahead.
Everyone, let's welcome Dr. Dharmaraj. Now, I would like to introduce you to Dr. Dharmaraj, a scientist being in biostatistics, bioinformatics, has an impressive academic and professional background, including a PhD in statistics from Banaras Hindu University 2018 and a Master of Population Studies from the International Institute for Population Sciences 2013. His research focuses on biostatistics, population studies, and public health. With over 20 published papers in esteemed journals covering topics such as air pollution, mental health, and socio-economic studies of laborers. He has received several prestigious awards, including the Professor S.N. Singh Award 2020 and Junior Research Fellowships from CSIR and ICMR. A participant in international conferences in Malaysia and Bangladesh. Dr. Raj is a life member of professional organizations like the Indian Association for Study of Population. He also authorized the book Quality of Life for Intergenerational Mobility of Living 2018, reflecting his commitment to impactful research. We are very grateful for his presence today. I would like to invite Dr. Raj to come up on the stage for his presentation. I would like to call Dr. Munishwaran sir to welcome Dr. Raj to the bouquet.
आपको कौन अच्छा लगेगा?
So we are glad to have you here. The stage is all yours.
Good afternoon. Good afternoon. Better please adjust the mic.
Yes. So, in today morning we have four lectures and this one is offline. So, person will communicate here. And as our topic, environment traits. with environmental information with application of statistics. So this term is environmetrics. So data, computation and communication as theme of this international conference. We learn about our data, computation in the field of environment. So please, as we know, overall universe, we have a progressive world, developed countries. So, universally, the rapid pace of economic growth has been accompanied by the resource depletion and environmental depletion. हम जितना प्रोग्रेस के देख रहे हैं उतना हम अपने एनवायरनमेंट को कहीं कहीं निग्लेक्ट भी कर रहे हैं AI and water pollution, water scarcity, desertification, and the depletion of natural resources are beginning to have an adverse impact and almost the whole of the economic activities by causing severe disasters such like flood and landslide. In last rain season, we have seen the Barnard, there is a big disaster. So this type of the cases also ongoing happening. So we have these data sets are not with us. Please next. The environment, as this is a physical and biological combination of the organism and physical process as well as the interaction that occurs between the organism process and its surroundings. Indeed, of the earth, as our whole earth is a complex system of the interaction physical and biological process. Next, please. When we looking from a satellite on our earth, we see there is a lot of variability in terms of temperature. Earth is also moving physically in which we are placed here, like our lot is also variable. So this is a very big phenomenon and a lot of information at each point of second we have generated and stored. So to address these problems, a broad-based program of environmental policies and regulations is needed. Such programs require that we collect and compile authentic environmental data are used by the government official and other decision making. Data related to existing environmental conditions such as crucial for environmental planning and decision making. India is in the path of rapid economic development and will therefore need a closely collect and collect the environmental statistics. So, environmental data is very challenges to capture and analyze and as communicate this information. Listeners, the objective of environmental statistics is to provide information about the environment, its most important changes over the time and the classification, and the main factor that influences them. What environmental phenomena is happening, we know, but what are the main factors which is the interaction between them? So we need also to learn about them. Ultimately, environmental study aim to provide high quality statistics information to improve acknowledgement of the environment and support evidence-based policy and decision making. To provide the information for the public as well as specific user group. So we have a data, big data, but who use that data? So this is also a question mark for us. To available data is available is up to the public person, or is up to only government person, or some social environment who take this data and who implement under real grant. And one health equilibrium. So just like one health, anyone can explain just term audience what is one health. Just like we know, survey bhavatu sukhina, survey bhavatu niramaya. So everybody wants to be happy and healthy. Healthy person. So our government also recognize our also in motive every person have a healthy lifestyle, a healthy quality of life. So just in line of the way, Ayushman Bharat, PM Awas Yojana, PM LPG, PM Ujjwala Yojana. So every person, a government through all India, through all citizen of the country, want to meet at least a base level, a basic requirement there. So one health equilibrium, everybody want to meet the environment. So in this way, ecosystem and humans both are in a parallel. Humans are not separate from their environment and other species. We are in a common in our environment. So in this time, climate and health, many climates, temperature is rising, what effect of temperature, rainfalls scenario is also changing. There is some peak rain, there is where a lot of flood is coming, and there is some places where no rain is there. So this uneven has caused many problems. Just like there is a 50 villages, let's suppose 50 villages, and one person dies in one village. One person dies. I think they had no problem. But from 50 villages, 50% dies among one village. So this is the problem. अगर हम बात करें कि भी सब 50 गांव में एक आदमी मर गए तो कोई दिक्कत नहीं है, हर गांव मरे। लेकिन अगर एक ही गांव 50 लोग मर गए तो उस गांव के लिए डिजास्टर है। तो जो भी इक्विलिब्रियम है हमारी सोसाइटी का, चाहे डेथ पे हुआ, चाहे बर्थ हुआ, किसी भी लोकेशन पर अगर ज्यादा बर्थ हो गया तो वहां के लिए भी प्रॉब्लम है। तो इस तरह से हम पूरे इन्वायरमेंट को एक इक्विलिब्रियम में चाहते हैं। जैसे मान लीजिए बीआईटी का अपना नीट क्लीन इन्वायरमेंट है, ऐसी तरह ही अगर हम सिटी में जाते हैं तो वहां पे हमको नीट क्लीन इन्वायरमेंट मिलना चाहिए। हम किसी स्लम एरिया में गए तो वहां पर हम क्या 1 घंटे खड़े हो सकते हैं, किसी विलेज में गए तो वहां का क्या सीन है। तो हम जहां भी मतलब ऑल अक्रॉस कंट्री हम चाहते हैं कि एक अच्छा सा एनवायरनमेंट हो। हम सिर्फ बात कर रहे हैं अक्रॉस द कंट्री, बट कहीं कहीं हम बात ग्लोबल लेवल पे भी डिस्कस करते हैं। नेक्स्ट प्लीज। The framework for the development of environment statistics was published by the United Nations in Statistics Division, UNSD. First time in 1984, UN decided to have globally for environment. There is a 6 concern: environmental condition and quality, environmental resource and their use, residual stream event and disaster, human settlement and environmental health, and environmental protection, management and engagement. This is 6 aspects. From globally, we can discuss about the environmental data, environmental statistics. Next, please. So, just about what slide is go. There is many issues and their socioeconomic importance. Biological resource, mineral waste, human settlement, natural disaster. There is such parameter on which we focus, just like waste management. Municipal waste disposal, generation of hazardous waste, import and export of hazardous waste. Just like in our campus, daily how many kg of waste is coming? Among that, how many percentage it is hazardous? How many percentage is biodegradable or not? So each information is a data for us, because we are human living and living in our environment. We need every information. Next, please. So Government of India, under the Ministry of Statistics and Program Implementation, every year government publishes environmental statistics about India. It's the same pattern of UNSD. So each this is the site where you can see the each information, just like due to climate disaster, how many deaths each state is the each information is available in the government side. Please next. Environmental statistics and multidisciplinary cross-cutting the result information. I request if internet available, please connect this
Please connect this website.
website. Yeah.
Click on that one.
Sir, it's link is
Will not which copy and
Yes, sir.
open on Google Play.
It's not open.
So the word count, this is a site, website, anyone can access from their phone mobile. Here we see turn of just from household. Globally today, globally in this year, how many tons, how much ton of just is generated? There is a this month at today, we just click on today. So today, globally, more than 28 lakh ton just generated today. And please go down. Turn at electronic just throw out. This is all information globally which we can see in this. This is a secondary data source. All data has compiled from various sources. This may be personal, governmental, any non-governmental information, all which it compiles. There is some one organization which compile all information. So on the top page there is a world population. World population, yes. So in country India, yeah, right, yeah. India is any one country just like India. So the population of India will grow from 1.37 billion in 2020 and 4.5 in 2030. So this is the huge number. So for this population, what is the resources, what type of in any individual, what is food rate, what is water, what is जो रिक्वायरमेंट है उसको कैसे फुलफिल करेंगे और उसकी क्वालिटी क्या होगी जो हम कर रहे हैं। जब लाइक अगर सिंपल एग्जांपल अगर बात करें, जैसे हमारे खाने की थाली में सलाद आ गया, सलाद हो रही थी,
दो तीन रहती
कि
दो रहती
हमारे प्लेट में सलाद आ गया और हम उसको टेक करते हैं, कोई उसमें एजुकेशन करते हैं। अगर हमको दिखाया गया कि एक प्लेट में वो सलाद है जो अंडरग्राउंड वाटर से उसकी सिंचाई हो रही है, दूसरा प्लेट में जो सलाद है वो उस खेती से है, उस एग्रीकल्चर लैंड से है जो शहर के जो वेस्ट वाटर है उससे सिंचाई हो रही है। लेकिन आप जब सामने प्लेट में है तो वो आपको डिफरेंस पता नहीं है, लेकिन अगर डिफरेंस पता है तो आप क्या प्रेफर करेंगे? अंडरग्राउंड वाटर, क्लीन वाटर। इसी तरह जब डेटा हमको मिल रहा है, जो भी डेटा अथेंटिक है उसका सोर्स क्या है, वो जहाँ कलेक्ट हो रहा है वो कितने क्वालिटी से कलेक्ट हो रहा है डेटा, उसकी अथेंटिसिटी है कि नहीं है, वो हमको किसी भी डेटा को कंप्यूटेशन बेस पे जाने से पहले उसको हमको चेक करना होगा। तो डेटा एंट्री, डेटा कंपाइलेशन इज मेन चैलेंज। जनरली we have secondary data on our website, mainly we just download and analyze everything. But where we cross check our data is authentic, have solid quality. Because on plate everything is okay. But what is the base? The result output of drainage, water of drainage make our life destroy many of diseases in long time. have our health problem. So our data should be authentic, neat, clean for computation or communication. Please, yeah,
PowerPoint.
PowerPoint. So there is another, you can check world meter that information. We move ahead. So our this talk is just only sensitized to our data quality. And environment aspect is also not just like artificial intelligence tool for robotic system. So health concern from this major people here, we also request to work in the environmental aspect. So we our future have good quality of life instead of that air, water. So ultimately environmental data computers and computers serve as a powerful framework of addressing global environment issues like the climate change, population, pollution, and resource depletion, enabling the efficient life, or solution of sustainable development and environmental protection. So I hope our next people work in this field. Or nextly, if any project you like, any your thought, so PhD work, dissertation, internship, want to work with us, please you can take the email ID. Even if any types of discussion with me, so we can work together. If any query from audience about environment trees or any other health related information, can please welcome.
Mike.
Next slide बोलो. Next slide.
Am I audible?
Yes.
Sir, a very nice presentation towards the showcase of environmental problems related with the data communication and data pre-processing and other. Sir, one question is that means for collecting the data regarding garbage all over the country, is there any computational unit set up by the government of India or nearby the some cities is setting by the government of India for collecting such data and information? Actually, you have shown for global collection of garbage day by day or every time. So, is there any scheme for the Indian from the Indian government to show that how much garbage we are collecting, we are gathering, creating day by day?
Currently, for just like Nagar Nigam, Nagar Palika, many have their vested system to collect garbage and process that garbage, segregate that garbage in many on the base of their hazardous and biodegradable. So this is the data, just like in rural area, there is a auto system in the village, no collection. But small towns in township also start this work. So this data is just like today data is not current there, but today data can be predict for tomorrow. So future data, past data, they use here for today prediction. Yes. What is the estimated garbage for a particular day? They see from the season to season, day to day, whole year of information can like for next year. Just like this CPCB, Central Board of Control of Pollution, so that have taken data air monitoring. Just like today particulate matter, they have near about 558 stations overall the country. So each day they catch the data about the air quality information. Then what level of CO2, what is level of O2, what level of wind direction, temperature, relative humidity. So each information is constantly gathered. But today data cannot reported at the same day. So this is the predicted information, forecasted information from our past information for today.
Yes.
On, it's on, sir. On, yeah.
Good afternoon. I know you are a very nice person to interact with. I hope our faculty and students will have some sort of association with you in future. So this is actually not a question to you. This is I would like to share with my faculty and students. Faculty and students, Dr. Dharmaraj is a very simple person. He is working on statistics and particularly on environmental sciences. All of you can contact him. He has shared his email address. You can write a mail to him. And so those who are doing MTech, some of you are doing MTech, right? So you can do internship with ICMR. So they have many projects. You can work with them and join with them in their laboratories. So this is a chance for you. I think some of our faculty are already discussing with you in the morning. So hopefully some fruitful work will come up, I think so. Thank you, sir. Thanks for joining us.
Thank you. Thank you.
Sir, I have a small.
Yeah, please.
Sir, it was a nice talk. You presented so many things, but and we also read yeah, we read that almost all the time, like in newspapers, that so much concern is there about environment. And I think in BTech and masters, we all students also study this as one subject, environment. But after that, I don't think anyone is taking this seriously. Because like we know that Himalayan mountain system, that is so much, very much new mountain, and we should not make constructions on that. But situation is like that, we have to do that. We have to make tunnels, we have to make roads. So because of that, so much damage we are creating to environment. And the wars in across the world, like Ukraine, and so much war is taking place, that is also causing a lot of work. Are we really serious about taking care of this? Are we going to do like whatever everyone is like? We are using ACs, air conditioners, they are causing so much damage. We are using petrol fuel car, they are causing so much damage. Are we really serious? Or we are just talking about this in editorial newspapers and meetings? I think you are the best person, you can answer this question.
This is the just like अगर हम क्वेश्चन की बात करें कि hen and egg who come from, हम सीरियस हो रहे हैं कि नहीं हो रहे हैं, ये भी एक इशू है कि जब तक हम सफल होते हैं या सफल नहीं होते हैं तो हमारा एस्पेक्ट क्या है कि जब हम प्रॉब्लम फेस करेंगे तब कंसर्न ले या प्रॉब्लम फेस करने से पहले कंसर्न ले। तो एक इंडिविजुअल थॉट्स है कि कौन पहले कंसर्न लेने को तैयार है। जैसे कि अगर कहीं पर कॉन्फ्लिक्ट हो रहा है, अगर एक बहुत ग्राउंड लेवल पे एग्जांपल मैं दूं तो अपना छोटा भाई 10th पास हुआ, बाबूजी इसको बोले कि जाओ नेबर का पैर छू करके आओ आशीर्वाद ले लो, तो वो तो गया सबका आशीर्वाद लेकर आया, फिर हमसे पूछने लगा कि बाबूजी भेजे कि जाओ सबका पैर छू के आओ, घर वालों का तो ठीक है लेकिन सामने वाला को क्यों? क्वेश्चन मार्क है कि क्यों, उनका क्यों? तो मैंने रिप्लाई दिया कि जिस दिन तुम्हारा एग्जाम था, अगर उस दिन पड़ोसी अपने घर से झगड़ा कर लेता तो तुम्हारा पेपर ठीक होता। तो पड़ोसी जो है हमारे घर से झगड़ा नहीं किया, तो उसने एक सपोर्ट किया हमारे एग्जाम के लिए। सो हमारा होल इन्वायरमेंट जो है, अगर कॉन्फ्लिक्ट होगा तब हम कंसर्न लें, या कॉन्फ्लिक्ट होने से पहले हम सबको इक्विलिब्रियम करें, सब चले। कंसर्न एक आदमी भले मतलब पूरे गांव में एक आदमी गड़बड़ होता है तो उसके चलते पूरे गांव वाले तो डिस्टर्बेंस नहीं करेंगे। तो कॉन्फ्लिक्ट मान लीजिए रशियन यूक्रेन चल रहा है या इजराइल वहां चल रहा है, हमारे दीपावली वाले पटाखे पे लोग बोलेंगे कि ओजोन का हो रहा है डिग्रेडेशन, बट इस पर कोई नहीं बोलेगा। सो समवेयर इकोनॉमिक सिक्योरिटी और पॉलिटिकल प्रेशर इज आल्सो in the environment concerns, So another where what happened, but if any smell is coming in this room, we are concerned about our. So we live ahead to Ukraine and go for our Indian neat and clean environment. I think just.
Thank you very much.
Good afternoon. This is Dr. Kumar Sami from School of CSE. Sir, may I know what are the research opportunities available as per student and master students and research scholars as well as faculty? So I hope in ICMR website every year we have a research proposal, calls and other things. So what are the every month we have a call, any such collaboration is available in from ICMR related to healthcare?
Actually, we just see on the website there is a card and we just start a write proposal SMS. Generally people working. But proposal is that from last 3 years we have worked on any issue. So we give enough time to writing a proposal. So that proposal have refined and submit to ICMR. So that get more chance to select one because there is a number of proposals coming and throughout the country just like मान लीजिए 10 प्रोजेक्ट का इंफॉर्मेशन है लेकिन 1000 प्रपोजल आया तो सबको तो मिलेगा नहीं और जनरली एक दिन 2 दिन बैठ करके लोग अपना कॉपी पेस्ट करके प्रपोजल सबमिट कर देते हैं तो जो फील्ड का एक्सपर्ट है वो जान रहा है कि इसके प्रपोजल कब बनाया गया है कितना था कितने पुराने लिटरेचर को रेफरेंस दिया गया तो कोई भी स्टूडेंट कोई भी फैकल्टी अगर प्रपोजल बनाना इनफ टाइम हमको देना चाहिए लास्ट 2-3 साल जो हम जिस फील्ड में काम कर रहे हैं उसी फील्ड को वर्क करना चाहिए 2-3 लोग मिल गए कोई थॉट्स आया उस पर कॉपी पेस्ट करके एक पेपर लिख के हम पब्लिश कर देते हैं दैट्स अनदर मैटर बट एज एक्सपर्टीज वी हैव एनफ नंबर ऑफ वेटरन एनफ नंबर ऑफ एक्सपीरियंस और एनी प्रोजेक्ट just with Dr. Sir, Dr. Harsan, we have write one proposal from last 2 years. So I hope in that next 5 to 6 months we can submit. We have able to submit. Just not last 1 month, 2 months we write one paper and submit this. This is a very less chance to select there. So please give enough time to for any calls.
Okay, sir. Thank you very much.
Thank you. Yes. Thank you so for your wonderful presentation and interaction. To reflect it, I would like to invite Dr. Anju Shukla ma'am to present a memento of thanks to sir.
Hello, hi.
Yes, yes, yes. You can share the screen and start. We are in live recording and your session is recording. So.
Yes. Sharing screen.
Yes, 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 it is visible. It is visible, sir.
Okay, is it visible now? Yes.
Yes, it is visible, sir, but not in the slideshow.
Made it in the slide, so.
I think, sir, you have to share the entire screen rather than application.
Sir, you have to go to
Yes, sir, it is fine. Please start, sir.
Okay,
Thank you.
so I thank DIT Bhopal for this keynote session. So I am Dr. Ashish Kumar Pandey. I'm working as an associate professor at C5 Foundation. So this keynote session topic is mainly on the low temperature bonding for the hypertrophic.
Paper ID.
So
Siddha sir, वो sound.
these are the outline for today's presentation. This is mainly the motivation of HPC, high performance computing. Then what actually make the HPC, not how we can solve it to get into the high performance computing at the IC level, with the device level. Then we'll move to the low temperature bonding, its results and different temperature bonding for the high performance computing. So this is the motivation.
Yeah.
So mainly high performance computing is the process of combining computing to provide
Just take 2-3 photos and go to lunch.
here mainly computers are clusters of computers.
Jaldi
We frequently refer to individual computers in a cluster. Each individual computer contains 1 or 4 processors, but how these processors are typically working in gigahertz or megahertz, and that all depends upon a device. So the mainly the started with the processors from 8085, 8086, then we'll be having the 80286. It's strictly isolated domain of cores. Okay, so there are various nodes are also available with the different core. It's mainly two parameters. This device level and house level. And say the gate oxide thickness is almost reached to the atomic level of shrinking, and limitation of dimensional scaling and complexity of the circuit and infinite RC delay. Mainly the RC delay, which will useful for one device to another device, data is transmitting that particular tau. So it's getting high. If the particular tau, which is R and C multiplicity is higher, then latency will be obviously higher and the bandwidth will be lower. So you can see one bandwidth to share the information is going to typically reduce at drastical level, exponential level. So in order to get rid of this, there will be a need of a paradigm shift. The paradigm shift is from the 2D integration to the 3D integration. Here I have portrayed one example mainly. Let's say this particularly IC, that IC consisting of all the memory, display unit, opto device, MEMS, then the DSP and the processor mainly with the ASIC, MCU, etc. So let's say this processor wanted to communicate with the DSP processor for particular application, a longer run of wire, which actually creates a more R and C delay, and it produces lot of latency and as well as the bandwidth. So what I have planned here, instead of using a longer run of copper wire from a device A to device B, there will be a splitting in the IC level. One that device A will be one of the IC level and device B will be another IC level, then both will be bonded with some temperature and pressure. So that main motivation is towards shifting with the paradigm from the 2D integration to the 3D integration. So now we come to the 3D integration. So mainly it is stacking of multiple devices that interconnect layers that electrically connected. That we have seen now, just now the paradigm said a device A wanted to communicate with B, that device A will be in one layer of IC, device B will be another layer of IC. So obviously there will be a connection required between them. That connection is through the TSB and mechanical strength with the bonding. The bond. Then now we move to the what type of bondings. There are different types of bonding, but for the basic bonding will be copper bonding because it is more conductive than the aluminum, and which is copper also can sustain more temperature.
Attendance. नाम आ जाएगा काम को.
And no intermetallic compound formed during the mass computing is very easy with that. It is roughness of the surface and the contamination of the surface. Once it goes to the ambient temperature, then there will be a chances of lot of oxide molecules that is going to be interact and that makes a silicon dioxide form and it will be more contaminated. Next, then just main challenges is surface roughness and formation of oxide, which makes the impact of bonding with the right? Yep. Temperature and highness. Required and a come up. So in order to avoid that, the mainly solution will be the methodology protection of top. Or surface guiding. Both is very thin layer. Better. So these are the typically scopes through a copper one thin panels we have done mainly for the FM and XPS, X-ray photoelectron spectroscopy, all these things, and we have found that just a 2 nanometer level of thickness of titanium as a passivation layer is much more important on the copper surface to make a low temperature of the surface. So that we have. And see, then we have cleaned those wafers, then transferring pattern these wafers with the lithograph technique. After that, in-plane deposition using physical deposition, PVD technique, and then we have used the litho using precipitation. Then I have used the thermocompression bonding with the optimized titanium. So this is mainly the experimental method we have done to achieve the low temperature bonding with 175 degree and 4 kilonewton of pressure. But you can see here, main alternate solution is required. Why the alternate solution is required? There are many advantages of TA passivation and many disadvantages also there of the TA passivation. Advantage is very important here. The porous material, so it will be mainly a very good advantage, so that copper can diffuse through the TA and protect the copper surface also. But mainly the low thermal budget is also an advantage. A disadvantage is the oxidation parameter. The oxidation parameter is not so high, so protect the TI as well. Once it also goes to the ambient
oxygen, then again it forms a TiO and TiO2. And also another disadvantage is when you go for the IC level, that benzene compatible is not proper. That's why we move to the alternate solution, which is called the metal alloy passivation. And this we have done with the instead of using normal metal to passivate the copper surface, we have used the protected copper surface by depositing thin layer of metal alloy. So that alloy will be having similar type of property, but little bit advantages. What advantages?
क्वेश्चन तो पूछूंगा ना मैं, ये क्या मेटल वेटल बता रहा है, ये नहीं आता मेरे को।
Copper can copper cannot form
इंडियन
any
पेटेंट
oxygen.
एप्लीकेशन।
And also conductivity of copper is much better than the Ti with the copper alloy. And also even copper can easily. And more disadvantage in Ti.
आपने किसी बच्चे को दे के रखा ना मीठो अपना।
But metal alloy proposed here is mainly the seamless. The patent is also, and the patent also get granted and
मैंने तो दे के रखा, मैंने दे के रखा है।
बच्चे बहुत ख्याल से
सर ड्रामा स्पीड भेजिए इसको ओपन कर दीजिए।
मैडम हो गई स्पीड।
So these are the different optimized also
अच्छा इसमें
how much maximum thickness
मैं तो बड़ा डिप्ली लेकिन वो मांग नहीं पा रहे हैं कुछ भी कर
we have done it for the
सर बैच में वाले कैसे तो इसको भी दो गया
the AFM and XPS we use that here we use the same technology along with XIS is also
क्या हुआ? हाँ उसी को फोन करें।
नहीं सर सर आ रहे हैं।
सर आ जाओ।
नहीं और भी हर जगह बोला आ रहे हैं
सर इसी कर आ रहे हैं।
आप चाहे प्लस
कौन सा डायरेक्ट कॉल वाला इनेबल करके रखा है सब
easily visualize here
कुन तुम से करवा दो, वो भी तो एग्जीक्यूटिव टीम है।
distinct and completely bonded mechanically strengthened.
सर कोई नहीं सुन रहा, आपको पढ़ा भी क्या रहे हो, मैं भी नहीं सुनूंगा।
And we
Water,
also check the thing with the reliability assessment because we know our process may be
कहाँ से पकड़ लिया आपने?
cycles and maybe not like we will be having different so we have done those reliability assessments.
इसका आपने वो भी बनवाया?
We have done multiple current tests. Thousands of cycles of current tests we have done for that interconnect, and we have seen that there is no degradation of specific contact resistance. Means if you have
So what is the use of your presentation?
No degradation, so it is very good method for the
इसको वो दिखाना पड़ता है ना
now we can also
सर्टिफिकेट।
another reliability assessment here, the temperature cycling test for the various temperature ranges from
किताबों में छप गया
very distinct change in specific resistance.
किताब भी लेके भाग गए सब। किताब
Conclusion of that
this is a best method on
reliability assessment and the best method for the interconnect of copper effects from the one and another reliable assessment we have done with the harsher environment.
उनका सिर्फ गोवर्धन दास का सर्टिफिकेट रह गया, बाकी सब चला गया। ये सबको समझ गया।
69% in temperature of 160
बस ये बोल दीजिए
very high accuracy, no again in the harsher environment, and with that accessibility we can able to identify and also globally we have verified this particular
वैलिडिटी
में तो यही होता
है
है।
उनकी प्लानिंग थी, हम तो वो एग्जीक्यूट कर रहे
better result for the copper pattern
उसी ने कुछ बोला है उनको समझने का हम लोग
so these are the
अरे यार मुनीश्वरन
optimally chosen alternate extension provides excellent
आजाद जबकि अभी वो है, आजाद कर रहा था कि हाँ फोटो होनी चाहिए।
हाँ उसने बोला
up to 150 with 4 bar bonding 4 bar bonding
यार उसको डिवीजन हेड बनना है ना, साइकिल मिला 24 कोऑर्डिनेट रहा
बायोग्राफी पढ़ानी है
capacity, which is, and also have done various reliabilities for the contract structure, like Arsal environment and
ये वीडियो क्यों चालू नहीं कर रहा?
cycle test.
इसको बोलो वीडियो चालू करके प्रेजेंटेशन देखो.
Level.
उसने भी रिकॉर्डिंग नहीं करा रखी.
हो सकता है सब यही चालू कर देता हूँ.
And also the interconnect can be used for HPC, which means high performance computing, which drastically reduces the latency and increases the. These are the few references.
तुम उठा लो.
सर ऑफलाइन बचा नहीं कुछ.
हाँ,
यस सर.
मैं तेरे को व्हाट्सएप करता हूँ.
यस सर. थैंक यू सर.
हाँ, 20 मिनट.
So I am stopping.
हाँ,
ओके सर. ओके.
ठीक है.
एनी स्टूडेंट्स, एनी क्वेश्चन? Thank you for your session, sir. Thank you very much. नहीं कर सकते.
Thank you.
Yes, sir.
Can I leave the session?
Yes, sir. Yes, sir.
Thank you.
Okay. Thank you, sir.
बोल भी देते.
इसमें कौन है?
सर अभी संजय पांडा ज्वाइन करेंगे 2 बजे. उसके बाद में 1:30 बजे अपना रामविलास पचौरी सर ज्वाइन करेंगे. बस 2 सेशन बाकी है अपने. ठीक है सर. जवान 1:30 को ज्वाइन करेंगे पचौरी सर.
रजनीश पटेल.
प्रेजेंटेशन
सर्टिफिकेट बनाना है.
बनाना है. सर एडमिट करना पड़ेगा आपको. 1:30 बजे.
मुझे मत करो एडमिट.
तो मैं एडमिट हो जाऊंगा.
आपको तो हो ही जाओगे आज.
संजय उन्हें कितने मैंने बोलना आधा घंटा 20 मिनट. ठीक है.
हो गया लंच? कौन आ गया?
Responses.
On Monday with him. No, not here. Not to them. We will get the message.
Do we write any, like yesterday we filled one attendance sheet for volunteers.
So,
I think it should.
volunteer.
हिमांशु है क्या? अरे उसका मेल नहीं आया मुझे. वो ओडी के लिए मैं भेज दूंगा ना.
कौन सी सर वो मैं आज आपको बना के भेजता हूँ ना.
हाँ तू भेज दे.
इवेंट के बाद
तो फिर हिमांशु को मत बोल के मुझे भेज दे कुछ. ठीक है.
And just making sure that your name is.
हाँ
सर उससे पहले वाली भी अभी तक हुई.
हो गई अपडेट. मुझे मैसेज आया हो गई.
तो हमसे क्यों बोल रहे हैं? आप तो सभी को आगे मुझे जानते हैं, मैं कौन जानता है? अच्छा, okay. उसका नाम लिख दो फिर। नाम वो कुछ वारंटी की लिस्ट बनाई है, वो बोल रहे हैं कि लिस्ट दे दिए। आईडी कार्ड जिसका बने उसका नाम भी होगा ना किसी लिस्ट में। उनमें से कुछ बच्चे ऐसा वॉलंटियर ऐड हुए।
20th Jan को first instructional day है।
हाँ 20
Please.
जैन को ना।
काम करते हो डेट के साथ ही भेजी थी पहले वो एक मुझे सुन मुझे शेयर्ड एक्सेल शीट चाहिए उसमें नाम रजिस्ट्रेशन नंबर जो है और तुम्हारा जो टाइम है ना लेक्चर वाइज वो एक अलग शीट में मतलब ऐसे स्लॉट के हिसाब से ठीक है सर बस जैसे आपको एक बार हिमांशु ने भी भेजी थी लास्ट ठीक है हाँ हिमांशु ने ऐसे भेजा ना वैसे हिमांशु या अभिनव दोनों में से किसी ने भेजा था एडमिट करो उसको और इससे सिर्फ क्वेश्चन ही पूछना है बस किससे दो तीन प्रेजेंटर है वो से
कहाँ है वो?
एडमिट किए नहीं आपने
कर दिया। उससे बोलो फिर से ज्वाइन करने की। जाओ भाई खाना खाओ आप लोग।
जाओ जल्दी ऑल ऑफ यू
पीछे आप लोगों ने खा लिया।
जाओ सबका खाना हो गया जाओ जल्दी
Yes, you can start your presentation.
Okay. So just
रिजल्ट सेक्शन
तो 3 मिनट में खत्म है, उसको चालू तो करने दो। 1:30 के पहले खत्म कर दूंगा। Yes, can start.
एक्सेंट को पकड़ रहा है वहाँ की नहीं कर रहने वाला है क्या हाँ तो ऐसे बोल रहा हूँ एक्सेंट को पकड़ रहा है वहाँ की अगर वहाँ से रहने वाला नहीं है खा लिया तुमने नहीं पानी में
We gone.
डायरेक्टर मारा कौन डायरेक्टर मारा
आज गए हो गया
अरे उसको रिलेशन निकालो यार अब हम लोग का कोई निकालना है
साथ में बने लगे
हाँ सर अब नहीं मिस्टर
आज वही है कुछ होगा
एमयू करवा रहा हूँ एमयू करा रहा हूँ डायरेक्टर कुछ काम तो नहीं है सर मुझे एमयू करा दे करके
जानते हैं
नहीं ऐसे नहीं जानता हूँ
डायरेक्टर ठीक है शुरुआत कम्युनिस्ट कुमार शुरुआत
हाँ क्या आशा खान से कुछ निकल
हाँ बोले यूपी के है ना
आपका कान को लखनऊ के होंगे वही शुक्ला है
अरे रजनी सर आपने फोटो डाली है एज अ कीनोट स्पीकर
हाँ कल डाली थी मैंने तो देख लीजिए आपने
अभी देखी मैंने
सारी मेहनत सर फिर से रखना पड़ेगा आपको सब अंदर
देखते हैं
ये क्यों बोला इनने कल देंगे अपने
सब लगा के रख दिए मैंने लाइन पे तो देने थे
कैन यू डायरेक्टली कम टू द रिजल्ट्स या यस यस
So the result is we were able to identify vulnerabilities in we were able to find vulnerability analysis rate, and most importantly, we were able to exploit the vulnerabilities in if you look over here at the left, we have a list of recent papers that we accumulated with three main categories. Number one, it covers all important regulatory facts, which some recent papers have and don't. Number two is remediations and lab manuals. In some recent papers have this category and don't. Number three is hosted in Azure Cloud for ease of accessibility. As you can see, all of them do not have this category listed in the research group. As well.
Okay, so I have a question for you. What is the real-time application of this?
The real-time application. Can you please
Where this model, whatever you have done, where this can be implemented?
Oh, it can be so this project is used for universities. So it can be hosted in the cloud, meaning that it can be accessed by anyone anywhere. However, specifically should specifically be utilized by so
apart from university, any other scope?
yeah, sure. And also, it can be used in universities but not limited. It can be used.
PPT submit करें अपनी कारण
Regular students. It can be used in jobs. It's employees and they don't know about vulnerabilities. And you can present them with this practical lab, and then they can go to lab and find all the vulnerabilities, the exploitation steps, and the remediation. So it can be, it's not limited only for universities. It's hosted in the cloud, and anybody can, even children, people who are in adolescents, they have interest in cybersecurity, they can use it, give out adolescents. So they use their jobs.
Okay, thank you.
Thank you.
You will receive your certificate in a day or two.
Okay.
Thank you. You can leave. Sir, good afternoon, sir. Sir, I'm audible.
Yes, yes.
Okay. Sir, we will start within 5 minutes. I will let you know. Okay. Thank you, sir. Sir, आ गया? तो भाई उसको बैठने दो, हलवाई बात करे। कचौरी चल रहा था माइक। रजीश कुमार पटेल sir, Pachori sir has joined. If you want, you can interact or we can start. Please.
We'll invite him for some other reason.
Yes, sir. Let's start video. Video cannot be shared, I think. Yeah.
Hello, sir. Good afternoon. Sir, this is Dr. Pon Harshavardhanan. Yes, sir. Nice meeting you. I'm here as Dean for Computer Science and Artificial Intelligence School. Nice to meet you, sir. Today we have expected that you will come offline so that I can meet you. Okay, okay. No problem, sir. Because I heard so much about you. Always, sorry, there is a problem with the camera. I can see you, but you cannot see me. So many people, when we said that you are coming, at least from 4 or 5 different people, I heard some good words about you. Thank you, sir. I should have met you today. We should have met. Then, yes, sir. Yes, sir. Yes, sir. Please come to the campus. We'll invite you for some other function. Please, that time, please join us. Sir. Sir, I think you can see me now. Yes, sir. Okay, okay. Okay, sir. Yes, sir. Yes, sir. And we are also thinking of coming to IIT Indore for some lab visit. When we come there, we'll definitely call you and we can meet, sir. Thanks, sir. Thank you for joining. Okay.
Okay, sir. Sir, we can, sir. Yes, sir, we can start the session. Sir?
I think mic is muted, please. Sir, I think we can start the session.
Medical image analysis. Yes, sir.
So, could we start?
Yes, sir, you can start, sir.
Okay, good afternoon, everyone. First, I would like to convert the actual conference organizers for providing part of this conference. This talk. Thank you very much. And let me share my slides. What is the paper ID?
Yes, sir.
So are you able to see the slides?
Yes, sir. Yes, sir.
So today's topic of the presentation is multi-channel data processing and towards medical administration. We start to see how to process this multi-channel data. And generally, the teacher is not interest to process data. And generally, what we process data in the channels. So in that way, there are certain limitations that we highlighted this law. And when you use joint channel processing or multi-channel processing, there are certain advantages. And our group will develop some methods for this multi-channel data processing that will be transformation that will be explained in this law. And we will see two types of applications. One is signal detecting, second one is epileptic. And there is a lot of actually use of such kind of methods. Because these methods can be implemented in the form of software, which can be integrated with mobile, smartphones, they can be urban areas also doctors can use such softwares for the patient diagnosis. So there is actually a lot of applications. So it is background to start the talk. So this is the overview. First we will see introduction, then we will see motivation, then propose multiple this then we see and after that we see so there is actually like real life we have very unknown signals. Signals in terms of non signals, not concepts, not data. Like the brain waves, the ECD has a lot of information about EEG, a lot of information. But how to explain? So one of the ways to represent signals in terms of systems. So here you can see the simple representation of signal that we use in 2007. That was the first formal signal that is Fourier based signal. So where we represent this complicated signal in terms of frequencies. So here you can see the signal is the first one, and second signal is non-signal. So first signal is a mixture of frequency components, and second one is combination of frequency. When you apply Fourier transform, then you see the spectrum that are two frequency components. And one of the serious transform here, because the spectrum is same, but signals are different. So spectrum may be corresponding to extension signal, this may be corresponding to non-extension signal. So due to that reason, there has been a lot of interest in the literature to come up with such kind of representation, which is unique for for spatial signal as well as non-extension signal. So in that way, there have been two directions in the literature. First is fixed basis direction, second basis function direction. So fixed basis functions, which include Fourier transform, Fourier transform, where we design basis function from our side, and then we represent signal forcefully in terms of the basis function. And second one is adaptive basis function, where we represent this signal in terms of
the basis function which we often follow. The basis functions are often for the signals, so they are added to their. So since basis function, when you represent signal in terms of basis function, basis functions, they are not part of the signal. They are the basis function. Sometimes if we don't represent the inherent feature of the signal, so they are independent. They are not part of the signal. So due to that, there is a lot of use of adaptive basis function. There is a lot of people are exploring adaptive basis functions. So where we use data dependent algorithms to obtain basis functions. So here, these are some mathematical models that we install. So first one, we are entering the sequence, they allow change to change with respect. So that and is suitable for narrow band. Then this is actually combine all of it. Then each component represents this five bands. And then because the line out of them for this model is used to us, where the vertical data and each element of each channel so what is the motivation for vertical data processing? So in real life, we find many scenarios then so for example, and also
if you want to, then I can ask this is your second year.
So in such scenario, if we process data individually, and if we not the population and also mutual information channels and these things actually the availability of the multiple sensors where multiple channels are recorded. On the other hand, we know about fixed processing. Each channel will give different number of controls. So in order to have the more linear property for this multiple data, there is a use to invest in the literature to develop multi-tense where you can use multi-tenant data, multi-sensors. At the same time, each sensor, each channel, each so the first technique is non-static signal processing technique, which without designing basis functions, there is a form of inverter post so here the signal that you provide and then take away of it, and then we subject the signal and then we satisfy the basic and it's not the basic functions. If it's not satisfied, basic and argument, otherwise we repeat this process. Like really welcome. And after that, two conditions for argument, indexable function. The first condition says the number of peptide and number of the process should be same or different at most value. So this condition ensures that and second condition says that zero discount is ensure that this function the first argument. First, I in other way, you can say that first I am the most skill operator. And great I am the longest skill. In that way, we say first I am last I am. Similar kind of way between in government without designing the system, without knowing the power of the government. This is the brief part of the advantage. So, based on this various multi-tenants,
you're married, right?
so in short,
What is the purpose of marriage? You for professional reasons. I will be.
highly
He's going to get both giant people.
And these symbols are only used for the diverse. This is
now how will this generation in your generation?
So different regions different parts of the brain. Whatever we do directly, then we can.
Then you can establish yourself, then you
system. And
maybe some other reason. When you start with the document, you have to take care of responsibility.
And depends, just for the example, when you go to
You have to take care of that. Prepare your husband to his office, right? Maybe that's the reason.
Either good method, if you see that three basic steps.
Either maybe this is also at the time. First reason or second reason. Maybe
Each segment will design then actually these regions we separate out. This our contributions as part of the then you propose the frequency so now if you see here that suppose you are multi-level data, and if you apply empirical data for each result.
यार मेरा इतना प्यार ये अपनी थोड़ी ना अरे हरी बेटी ये मैं कौन सा पानी इसके बाद लैपटॉप पे
So then don't so what you can take from this answer is separate from
करता है वो कर देता है मैं अप्रोच ही नहीं करता मैं कौन सा अप्रोच करता हूँ तो कह रहा हूँ मैं भी नहीं करता तू देख रहा है मुझे अबे भाई मैं तेरे को क्या मीटिंग बता उसमें टेंशन दे रहा है कि काम है कि मैं एक्टिंग करूँ नहीं ये सब मैं भी नहीं करता मुझे मालूम है जो टेंशन चाहिए वो छूट रिलैक्स कुछ भी कुछ भी नहीं चलता है ये तो तेज है मैं मानता हूँ लाउड स्पीकर पे सारे लोगों ने बोला अच्छा बात हो जाती है तो वो भी यही सबसे धीरे हमारे दोस्त पाते अभी कोई बात
the requirement of the process that you see in the website, where process features are given in the input process. Which kind of used for the diagnostic so this is one example here. This is 5 level CDF3. Please and this is multi-variable. Here you can see what this it's often time frequency so that is actually the first case this will be covers all so you can be good at signature software we are features
it's someone yes this one is
and you can see now and then we will see the events of interaction. Besides and then the works process so then we have see that we classify the approach classify and then we compare this versus the first method and you have put your terms and stay with you can see that after that, the other method will be conservation technique, we actually go to conservation. So here you can see this, this area proposed to one side, they are our extreme. And so how much frequency is and the proposed frequency becomes less and becomes higher and so automatically filter length is very for the lowest frequency so this at LX actually the frequency is repeated and next the signal so we subtract from the signal this signal and then perform this operation reasonable number of times you get first I subtract from the square and you get another first I like second I so then we will all possible so this is one example it is first three
have you ever wondered if you were up against a cheater in 8 Ball? We understand the frustration and we are fully committed to protect your gaming experience. Our advanced detection algorithms are now more effective at identifying and removing cheaters, while also improving
first I was checking the subject for the signal, other will get a part. So now this very quickly, this can be the group of the group. So for the signal, advice, filters, update for the signal, and showing that two shows that in the experience. This means number of extrema is greater than 3. This means there is oscillating nature, so then we talk about these conditions are also. Either case becomes stronger. Now, if we apply this concept for multi-channel data, then there is a lot. Because each channel will have different extremas, and we can compare them. So, in order to have one line of programming, what we suggest today for the multi-channel data, we find the number of extremas, and we have the maximum of that. Then we know the length, filters the subtitles, then change the scope of idea and consistency of idea, then post idea, then subtitles, the residual will be the same process. We get all possible arguments. This is just an example. Demonstration of idea. So the two channel filters, we take the maximum of what? So this is first one filter, so second one. If subject is first item, the first item, second item, subject of the signal, and the particular so this now what is the use of this multi-variable technique? So actually I see now this is a information. Then actually each which has come out from all the generations. So this kind of information and then can be used for example. Schizophrenia is for chronic
नहीं चाहिए पेन कम हो जाएगा
Different kind of this multi-channel becomes as a you see your multi-channel
हेलो हाँ सर मैं बोल रहा हूँ कुशाल हेलो हाँ सर वो जो टेक टीम में वो सर जो लैपटॉप वाला प्रेजेंटेशन वाला हाँ सर ये बोलना तो सर बहुत दो सर और है जो मीटिंग में ज्वाइन करना चाह रहे हैं क्या करना
what is So here you can see channel data. These are the objects that don't have one algorithms, but here you can see one process. They represent same frequency components. So this means that the whole array of and once you can frequency, we have separated out the and then the sequence so this is the type of then we have section set of features. I don't think we don't go into the comments. And they're using the CA and total feature not actually right. And in order to implement this
सही है ये ज्वाइन करना चाह रहे हैं बहुत सारा और ज्वाइन करना चाहते हैं एक और कौन है एक और सब पता नहीं वो भी आए थे
हाँ करते हैं सब बच्चे मैं भेजता हूँ वो भी संजय पंडित सबको इंट्रोड्यूस कर देना और इनको पहले थैंक यू बोलना नाम बहुत कुछ तो वो ऐसे
that's not certain this. And the performance of this system. And then you can see, stand for prosperity. So then it's just consider them for possible so we have compared our mind and other existing methods in the region. They also do similar personal scenarios. So our as compared to the other existing methods, which have been so this is a conclusion of this background. Proposed multivariate differential transform and multivariate general and I know that All they have the same number of not be particular single particular. Company itself. But the push methods. Push auto. Computers start those, but the network that can be used for diagnosis or disorders. This talking actually based on these two research papers. And because of the participants, they are more information about the work. Please go
Yeah.
through these papers. Any questions?
Thank you, sir, for the wonderful presentation, sir. धन्यवाद आपको बहुत 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 ज्यादा धन्यवाद सर। प्रणाम सर। मैं हिमराज, आपसे वार्तालाप किया था मैंने। यस।
Thank you, sir, for your presentation and for telling us the insights of this technology. Now, I would like to call and introduce Dr. Sanjay Pandey.
Just a minute, just. Sir, there are some couple of questions, but I think the students are a bit busy. So we'll take the question later, sir. No issue.
Oh, these are actually a request on the participants. Please type me the questions. Again, thank you very much for attending this talk. Thank you for the.
Sir, on behalf of VIT Bhopal University as well as ICDCC organizing committee, I would like to extremely thankful, sir, for your time. And next time, definitely you will be on campus, sir. धन्यवाद सर, धन्यवाद बहुत बहुत।
बस पेपर का सर्टिफिकेट दे रहे हैं उनको जाना, ठीक है।
Dr. Sanjay, just 5 minutes more and then I'll update you. Okay. आदित्य वो लास्ट में बैठे हैं, उनको बुला लो फोटोग्राफर। सर अनाउंस ही कर दो वहां से फोटोग्राफ।
Photography team, please respond, come to the stage.
किसके लिए?
Sir, we'll take from mobile. आजा.
Now, we would like to give the Best Paper Award for the ICDCC 2024. The award goes to the title Enhancing Dynamic Facial Authentication through HCI, which we found the best among all the 153 papers that we received. So the author is Saurabh Suman. Please give a huge round of applause for Sir Saurabh Suman. I would like to invite our Dean of SCAI to represent him the award. Please give a huge round of applause again.
Mobile
Let's
से निकाले तो.
show some respect.
Yes, just a minute, and then you start with the introduction of Sanjay. So good afternoon, Sanjay. I hope I'm audible there. Yeah, so I would request the Master of Ceremony to please introduce Dr. Sanjay Panda from NIT Warangal.
So now amongst us is Dr. Sanjay Panda. Dr. Sanjay Panda is working as an assistant professor in the Department of CSE at NIT Varangal, Telangana, India. He worked as an assistant professor and head of the department CSE at IIT Kurnool, Andhra Pradesh, and also worked as an assistant professor in the Department of IT at BSSUT, Burla, Odisha. He received PhD degree from the IIT Dhanbad, Jharkhand, MTech degree from NIT Kerala, Odisha, and BTech degree from BSSUT, Burla. He has 10 years of teaching and research experience. He received 23 awards from IEEE, IE, ISTE, CSI, and others, which include 2 silver medal awards for the best graduate and best postgraduate in CSE. He is listed in the top 2% of the world scientists in a single year. In fact, as a survey conducted by Stanford University, USA, in October 2022 and 2023, he has published 130 plus papers in reputed journals and conferences and edited 4 books. He is a member of IEEE, IE, life member of ISTE, and life member of CSI. His current research interests include cloud and fog computing, artificial intelligence, machine learning, and Internet of Things, or IoT. He delivered 200 plus invited talks and chaired sessions in many national and international conferences. So now, we would like to welcome Sir, and the stage is all yours.
Yes, you are audible. Sir, उसका volume बढ़ाना है आपको. ये तो सुनने बढ़ा. Yes, it is visible. You can start.
data computation and communication. Dr. Hemraj and Dr. Virendra are giving me an opportunity to speak to the audience, participant, researcher who is associated with this conference. The title of my talk is Osmotic Computing, which is a new computing paradigm in the field of computing. So, osmotic computing was introduced in the year of 2016, and it is merging different computing paradigms or different technologies. So, I'll tell you about what is osmotic computing in this keynote. Also, I'll highlight that what are the research trends going on in the field of osmotic computing. But before going to that, let me tell you that we have a three-tier architecture. The bottom tier architecture is our Internet of Things, and the middle tier architecture is our edge computing. And on top of edge computing, we have the top tier architecture, that is cloud computing. So this osmotic computing paradigm is in between the IoT and edge, and it is also present in between edge and cloud. That's why the title of this talk is an emerging paradigm, that is osmotic computing, or cloud and edge, cloud and edge, and IoT. These are the topics that we are going to discuss in this session. I'll tell you the relationship between different computing paradigms and IoT. Then I'll tell you about the osmotic computing ecosystem. Then the importance of the osmotic computing with respect to the service migration. And also we are going to see some of the applications of the osmotic computing, followed by the research trends and conclusion and references. Coming to the osmotic computing, it is a completely new computing paradigm in the sense that it is integrating multiple computing paradigms. So earlier, before the arrival of the osmotic computing, there is not really research done in the field of IoT, edge, fog, and cloud. But these computing paradigms integrate all these technologies into a common platform, or it is providing a platform so that we can perform our task in multiple tiers. So it can be visualized in a 4-tier architecture in which we have IoT, edge, fog, and cloud. And when we visualize a 3-tier architecture, then we consider IoT, edge or fog, and cloud. So why we need this osmotic computing paradigms? What is the lacuna with the previous computing paradigms? So if you look into other computing paradigms, they cannot handle latency sensitive data. Nowadays, if you take an example of a healthcare application, or you take an example of intelligent transportation system, where latency plays a very important role. But when you go for a cloud IoT centric architecture, it suffers from various types of challenges like latency, bandwidth, resource constraint, and so on. So this computing paradigm is providing the promising solutions for handling very large amount of data which is generated by the digital devices. And you know, in day by day number of devices that is adding to the network is exponentially increasing. Like if you talk about IoT devices, number of IoT devices are very large number, and day by day this number is increasing as per the statistics given by different forums. So in order to handle this data, in order to deal with the latency sensitive data, so we need a computing paradigm that is called osmotic computing. Not only that, osmotic computing is also looking for the solutions of the deployment of the microservices, migration of the microservices, and optimization of the applications. Earlier architectures are dealing with either service-oriented architecture, or they are dealing with the monolithic architecture prior to service-oriented architecture. So if you look into that particular architecture in which the whole application is treated as one, there is no smaller unit in that particular application. So if an application is failed, that means the entire unit is going to be failed. That's why in order to avoid that dependency, people have come up with the service-oriented architecture in which they divided the entire application into different type of modules. And subsequently, people have come up with microservices to deal with a very small unit of works, so that impact of one work should not be happening to any other one.
So when we talk about this microservices deployment, migration, people are using for the osmotic computing solutions. Similarly, if you go for osmotic computing, not only it is applicable for healthcare or you can say our intelligent transportation system, but it can be also applied where you need latency is where you can think that latency is more important. So some of the other applications like smart city, education, industry 4.0, all these are can be visualized or can be implemented using osmotic computing paradigm. Now, if you go to the cloud, cloud can handle machine amount of the data, it can have large amount of storage, computation power, its network, it has so many things. But when these IoT devices are dependent on the cloud, and they periodically or frequently they push the data to the cloud, it is very difficult to manage this thing in the cloud. So cloud-centric IoT architecture is not sufficient to handle voluminous amount of the data. So if the data is not handled properly, it will impact the quality of experience, it will lead to user dissatisfaction and other things. In order to avoid this, people have come up with a intermediate layer in the cloud IoT architecture, that is fog and edge computing. Although fog and edge computing both are different, but these terms are used alternatively when we visualize a three-tier architecture. So in order to deal with the fog computing filters the data before sending to the cloud, so that the burden on the cloud is going to be reduced. So first it will come first a IoT device is communicating with the fog computing resources, and if the fog computing resources is sufficient, so it can handle it, then it is very good. It will not go to the cloud. But when the fog computing layer is insufficient resources or incapable of handling a particular request, it will push the data into the cloud. So fog computing can meet this low latency requirement, or it can provide solutions to the tasks that are latency sensitive. Like if you can talk about a smartphone or switches or routers, smart watches, this can be also considered for devices. Now, there is a slight difference between the edge computing and fog computing approach, although we are using alternatively these two computing paradigms when we look into a three-tier architecture. So as you can see in this picture, in the bottom layer, we have various type of sensors, we have actuators, and we have different type of controllers. So these sensors are deployed in a particular environment, and they are basically collecting the data. Once they collect this data, earlier they push all this data into the cloud layer. So cloud is overburdened, and there is a limitation with respect to the bandwidth, there is a limitation with respect to the processing, and ultimately latency plays a very important role. So now in IoT sensors and the controllers, if they need some kind of assistance, they can ask the edge layer resource. If edge layer can fulfill their requirement, then the result will be returned to the IoT sensors or the devices. But if edge layer is incapable to do that, then edge layer is again propagated to the fog layer. Similarly, if fog layer is capable, it can handle and return the results. Otherwise, it will push the data to the cloud. So, if you talk about this edge and fog layer, it can provide you better decision making compared to the cloud. That's why this realization of the fog computing, which was by Cisco, is well adopted in by the research community as well as the industry. And also, you can see when you go for a business opportunities, you are meeting with urgent demand. Here, the fog and edge layer can help. So it is also supporting the multi-tenant architecture where you can have a single instance of the software that can be run to execute the request of multiple customers. So in this way, the four-tier architecture can help to reduce the latency and enhance the capability of cloud near the IoT devices. Now, where this post-processing computing plays an important role, that you can see in this picture, where the outer layer is nothing but our IoT layer, where we have different type of handheld devices, just like our smartphone and smartwatch, router, and cable. And these devices can pull the data to the edge layer, which is a complementary to the cloud. And edge layer, if it is incapable, they are putting to the inner layer, which is cloud. It may be a public cloud, it may be a private cloud, or it may be a combination of public cloud and private cloud. So, osmotic computing focuses on systematic resource allocation between IoT layer and the edge layer. Also, it provides a systematic service allocation between the edge layer and cloud. And the concept of osmotic computing came from osmosis phenomenon in chemistry. So, in osmosis phenomenon, there is solute, there is solvent that can help you to take a decision that whether to move from high area to the low area or to low area to the high area. It is also well suitable when you want to balance the load among multiple tiers. So osmotic computing can help you to balance the load in multiple layers. Earlier, also people have thought of that we can move from IoT to the cloud, but osmotic computing presents a platform where the resource request can be in both directions. It may be from IoT to the edge, or it may be edge to the IoT, or it may be edge to the cloud, or it may be cloud to the edge. So the resources are properly utilized in osmotic computing paradigm. Now, in order to meet the requirement of IoT layer, like latency sensitive solutions, low energy usage, proper usage of the bandwidth, osmotic computing can help these devices to process their data near to the edge, or it can provide a proper decision making process to decide whether to execute it in the edge layer or it should be migrated to the cloud. Like when we talk about the microservices, if you take our e-commerce sites are having different type of units, like one unit is auto receiving unit, another can be considered as shipping unit, another may be monitoring unit, another is payment unit. All these are treated as a microservice. So once we represent a particular application in microservices, it is completely lightweight. So if it is lightweight and if a particular module is temporarily down, it is not impacting the others. So it is also microservices can be independently deployable and it is a very tiny services. So it is managing of these services is much more easier compared to monolithic type of services or service-oriented architecture. So osmotic computing improves the modularity by which it is representing dealing with the microservices and it is increasing the cohesion and decreasing the process of coupling. Now, if you see into the osmotic computing ecosystem, the ecosystem contains 5 important components. The first component is called a solute. Solute is a resolvable component, just like I can say solute is nothing but salt or sugar we can take in the picture. Similarly, the second component of the osmotic computing is called a solvent, which dissolve the solute. You can consider water is considered as a solvent. And the solution is nothing but what is the ratio between the solute to solvent, that is called as concentration. And a proper solution between the solute and solvent need to be considered in order to balance the property. Apart from these 4 components, there is an important component in osmotic computing which we call a semi-permeable membrane or we call a software-defined membrane, which you can see in this dotted line, which is in between 2 different layers. It may be in between the cloud and edge, it may be in the edge and IoT. So you can see in this particular picture, like if you see these are 2 type of symbols we are using in this picture. One is the diamond symbol, which represents solvent, and this symbol represents hexagon symbol represents the solute. So if you look into this high solvent concentration or low solvent concentration, you can see the number of solvents or amount of solvent is quite more compared to the solvent, which imbalance the particular. That's why if I migrate from high solvent concentration to the low solvent concentration, or it may be low solute concentration to the high solute concentrations, then I can balance the load. So before applying this osmosis, the load among these two layer is the load is not properly balanced. But when we move from the high solvent to the low solvent area, or we move from the low solvent to the high solvent area, then definitely the load can be balanced.
So in this way, the osmotic computing phenomenon which they are used in the same thing is applied in the field of osmotic computing. But the challenging part here, how to take an intelligent decisions to migrate from the high solvent area to the low solvent area, it is quite challenging. So in this regard, people have come up with different type of solutions. Like they have used osmotic decision maker. Process osmotic decision maker takes a decision that whether it can be solved in the same layer or it should be migrated to the upper layer, so that the load can be balanced. So in technical terms, you can say this solute is nothing but how much processing time is required to execute in a resource. It may be how much load in a particular resource. It may be what is the amount of power required to run this particular resources or amount of energy consumption by this particular devices. On the other hand, if you look into the solvents can be considered with different type of applications. It may be microservices, it may be ultra microservices, it may be macroservices as well. So these computing paradigms help us to move from one area to another area to balance the load. It is not only one dimensional. Always we are not moving from high solvent area to the low solvent area, but sometimes if there is a requirement, if the low solvent area becomes the high solvent area, then we can move from the high solvent area to the low solvent area as well. So that's why the the load can be balanced by a bidirectional approach, not necessarily unidirectional approach, which is used in the legacy system. That's why these computing paradigms are more popular compared to other computing paradigms. So we migrate across cloud data center to the edge devices or edge devices to the IoT devices, and vice versa also we can do software defined membrane or we call it the osmotic membrane.
LinkedIn पे था
Now, coming to the research aspect, you can see there are several challenges with respect to osmotic computing ecosystem. It is a part of a distributed system. It is completely distributed, and all these environments are federated and they are combined to provide the resources. So, automatic deployment of the microservices in such a complex architecture is really challenging because all the computing nodes that are part of this particular ecosystem, they are having different configurations. Like you can see that the capability of a smartwatch is different from the capability of a smartphone. So, how to deal with this highly distributed and federated environment? How to make the deployment of the microservices? How to manage these microservices is very challenging. The second aspect which can look into that is seamless co-location of the cloud edge for service migration. What decisions you should take in order to decide that it will be migrated from one layer to another layer, or it will be migrated from an upper layer to the lower layer or lower layer to the upper layer. So migration can be done with respect to the hot migration, where you need to immediately migrate and resume the work, or you can think about that migration can be done in a cold migration way, where you will suspend the resources, where you can store the resources, and you can resume the resources in another way. That's why seamless co-location is really challenging when we think about service migration. Similarly, another aspect which we can look into osmotic computing is that tunable configuration of resource utilization. We are migrating from one layer to another layer to improve the resource utilization, or the resource requirement is unable to perform in the lower layer. That's why we are migrating to the upper layer or vice versa. That's why what are the parameters, what are the thresholds you need to maintain in order to migrate from one layer to the another layer? That is deciding that particular parameter is always a challenge. And many people have come up with the various type of machine learning techniques and deep learning techniques to provide a tunable configurations. Another aspect you can see that is controlling, managing the service networking. At any point of time, a device will leave the network. At any point of time, a device will join the network. So, such a type of uncertain environment, how to deal with that particular environment for resource allocation is very challenging. And ultimately, latency is the major factor for which we are going for osmotic computing paradigm or fog computing paradigm or edge computing paradigm. And many people have also started with doing energy consumption, in which they are looking for energy efficient osmotic computing platform. They are not only looking into how faster you are going to execute, but also they are looking for what is the amount of energy it is going to consume. Similarly, if you look into the osmotic computing system, there is another important part that is called as micro element. An IoT application in a federated and distributed environment is represented as a graph of micro elements. So these micro elements can be divided into two parts, where you can say there is a data part and there is a service part. So microservices implement distinct functionality that are deployed and migrated across heterogeneous platforms. Similarly, if you think about microdata, that characterizes the bidirectional flow of domain-specific data across the IoT devices. So data focuses on how to make the flow between different layers bidirectionally, whereas service is focusing on how to deal with the migration in a heterogeneous platform. Again, this data and services can further be divided into operational and user in both ways, right? It can be a micro operational data or micro user data in micro data. And in microservices case, it may be micro operational services or it may be micro user service. So this is the hierarchical structure of the micro elements, and how to manage this is really challenging in this particular environment. Now here you can see how the micro elements are migrated from one layer to another layer. So if you look at this cloud edge layer, you can see the number of edge micro elements are quite more compared to the number of cloud micro elements. So what we can do here, that migration from cloud to edge is very less and migration from edge to cloud is quite more. Similarly, if you look into this edge and IoT, you can find that number of IoT micro elements are quite more and number of edge micro elements are less. So there is a migration from IoT to edge. In the similar fashion, we can visualize from cloud to edge as well as edge to IoT. That's why people have also come up with different type of solutions where they want not only this migration, they are focusing on energy efficient, energy aware osmotic computing paradigm. So the migration is also is a overhead or it leads to more energy consumption. Now, if you see the entire terminology into a single picture, so this is a 5-tier ecosystem where our bottom layers are IoT devices, and this is the edge layer where we have different micro data center, and the top layer is our cloud data center. And in between two different layers, we have a osmotic task manager. That task manager decides whether to migrate from IoT device layer to the edge computing layer or edge computing layer to the IoT device. In a similar manner, we are looking for edge to cloud and cloud to the edge. So this ecosystem is designed in such a manner that any type of applications, whether it is a latency sensitive application or it is a latency tolerant applications, that can provide the solution. In case of latency sensitive application, people can think about edge computing layer, but when they are going for latency tolerant type of applications, they can think about to go for the cloud. Then we can implement this in the form of different type of gateways. Like I can take a Raspberry Pi kit or I can take a Arduino kit, and these IoT devices sensors can be embedded into that, and I can decide that whether to execute in the kit or router or gateway or migrate it to the cloud. Now you can see in the security perspective also osmotic computing is largely used. So here I am specifically showing you two different layers. One is the edge layer and another is the cloud. So there are different type of microservices that we have used here. Like there may be a microservices with respect to the network management. There is a microservices with respect to the security management, or it may be a general purpose microservices. So in each and every data center, whether it is a edge data center or cloud data center, you can see there are general purpose microservices. But there are some specific edge data centers or cloud data centers are there, which is having microservices for security management or microservices for network management. Or in order to fulfill the quality of service, people have a specific type, providing a specific type of services in a edge data center and cloud data center. For example, if you see this particular edge data center, which we call as R edge data center, it is not providing you the microservices for security management. So in order to get a particular services related to the security management, either you have to use edge data center S or edge data center T. Similarly, one particular data center which is having security features that can be connected to the cloud data center where the security features are available. So that if it is not satisfied in edge layer, then we can migrate it in the cloud. So in the similar fashion, if you see that there are lot many research areas are there that where cosmetic computing can be applied. Like I am showing you the statistics up to 2030, where you can see people have applied the cosmetic computing in the field of healthcare. Because healthcare, we are monitoring the patient's status, right, or monitoring the health of the patient. So which is a latency critical application. Similarly, any monitoring environment like mines area, or you can say the area military or DRDO type of DRDO type of organizations where monitoring of the things is more important and it is latency critical. So people have applied in that particular area. Similarly, many people have, as we are talking about the security as a concept, people can think about how to apply it in the blockchain, in other platforms as well.
Hand it over to
Like
you.
that, people have applied in smart city application, people have worked in the micro element orchestration and networking, and there is some machine learning applications are there where they are combining one application with another application.
Total of
Which can
30
be-
bags.
This side.
Oh, sorry.
So as a conclusion, I
Tell
can
to
say
Devraj.
cosmetic computing paradigm is
Devraj.
integrating cloud, edge, fog,
We only
into one computing platform.
morning 20.
But integration is really challenging. And migration from one layer to another layer is really challenging because in each layer is responsible with a set of provider. You need integration of multiple providers into a common platform. So it leads to standardization issues, compatibility issues. That's why migration is really a challenge. And you cannot convince all the type of the service providers to come into a common platform to provide the services. So when we look into the business opportunities, it is really challenging. And in order to look into in a scheduling perspective or migration perspective, there is no standard data sets that are available which you can apply in the cosmetic computing. That's why there is no real life data sets, so it is really challenging to implement the things and claim that one particular approach is better compared to other. These are some of the references that you can go through. Thank you everyone. If you have any question, you can ask.
Yes, thank you, Dr. Sanjay. It was a very fantastic and fruitful session that you have delivered. There is only one question from the audience side. They have said that regarding security concerns. So how you will take that point into the dimension of the vulnerabilities which is increasing every single day. So how you will apply? Can you give some lights on that?
Yeah, I mentioned here that there are different data centers that are having microservices for security management. So attack is a obvious thing because it is a federated environment and it is completely heterogeneous environment. So the resources that are provided with different resources may get attacked by adversary. So we need a lightweight protocol in order to protect the vulnerabilities or attacks. We can avoid through by designing a lightweight protocol because we cannot go for a very heavyweight protocol which needs more
Correct.
authentications in order to compromise the computation part.
Yes.
So we need balance both computation part and communication part to lightweight protocol.
Okay. Thank you. Thanks a lot. And on behalf of VIT Bhopal University, I would really like to thank you for providing your precious time on Saturday. And I'm looking forward to you on campus maybe in the future. Thanks a lot.
Thank you.
लगा दिया इमेज नहीं है ना मेरे को नहीं पता ना आपको बोला बोल दो ना start करो. Who is there on the stage? Ah, yes, go ahead. Sir, can we start? Or we have to wait? Sarvanan S. S. D, sir. D, sir. So please start. Okay. D. D. बुलाने के लिए बहुत सरल सर ये ना साइबर साइबर come to auditorium. Sir. Hello. Yes, come to auditorium, sir. Sir is okay. बैठो गाने में लगा दो कैसे लगते हैं ऐसे ही बोला नहीं वो सर वेलकम फोटोग्राफी क्लब वालों को बुला लो तो वो गायब हो जाएगा सिद्धार्थ सर का है उनको भी बुला लो सर वो आगे बैठो ना ऊपर सामान दिखाने गए अब तो देखेंगे हम तो काम करते माइक रखा हुआ है इसको डालो तो बोलो कि आगे ना ये पीछे आपके बेटा इधर आ जाओ सर का फोटो निकालो बेटा के साथ साथ में आने नहीं तुम्हारा टास्क ही है नहीं टास्क ही था बंद कर दी भैया कौन है ना खत्म कर दो हो गया क्यों सारी तो स्पीचेस हो गए क्या ही होगा पूछ लो इनसे क्या करवाना है
कंप्लीटेड नहीं है
सर स्ट्रीम बंद करानी है चलने वाली
अभी ये लास्ट
नहीं पूछा मुझे पानी पूरी खाली हुई मुझे पहले की मम्मी हाँ फिर हो गया यार लास्ट क्या है पता लग जाएगा आप चालू रखो यार
past few days, we have observed the introduction of new releases, intellectual exchanges, and innovative ideas that definitely are going to stay with us in our fields of research and industry for a long time. On the behalf of the organizing committee, I extend my warm welcome to Honorable President Dr. G. Vishwanathan, respected Vice President Mr. Shankar Vishwanathan, respected Assistant Vice President Mrs. Kadambari S. Vishwanathan, respected Executive Dean Dr. S. Poolkunjan, respected Dean SCAI Dr. Pawan Harshvardhan, and our respected Vice Chancellor Dr. Senthil Kumar Arora. I extend my heartfelt gratitude to all the deans, directors, faculty members, participants, and students for contributing to the success of ICDCC 2024. I would like to invite Dr. S. Sarman, sir, to give us the welcome address to our valedictory ceremony.
Good afternoon. Good afternoon. Respected management, beloved VC sir, register sir, guest, executive dean sir, and various school deans, delegates, faculty members, participants, and organizing committees and volunteers. It is my great pleasure to extend warm welcome to all of you to the ICT CC 2024. Host here in VIT Bhopal University. We are gathered today with a shared purpose to explore, discuss, and advance the most critical issues face our industry, field, or area of interest. We will engage in insightful presentations, panel discussion, and networking opportunity, which will not only deepen our knowledge, but also strengthen our professional connections. We are glad to have expert thought leaders and innovators for all connectors of the world with us, sharing their experience and wisdom. Let us make this conference not just a meeting of mind, but also a collection of collaboration, innovation, and progress. Together we can make a difference. Once again, welcome all, and I hope you have rewarding and prospective experience. Thank you.
Thank you, sir. ICDCT 2024 brought together specialists, academians, and a company heads to discover how data, computation, and communication are changing at very fast pace. Now, I would like to call Dr. Anju Shukla ma'am to give us the highlight of our conference.
Good afternoon, distinguished guests, esteemed researchers, academicians, participants, and my dear students. I, Dr. Anju Shukla, representing as Stage Committee Lead at ICDCC 2024. It is my great privilege and honor to welcome you all to the International Conference on Data, Computational, and Communication, hosted by the School of Computing Science and Artificial Intelligence at VIT Bhopal University. This conference stands as a beacon for innovation, collaboration, and exploration in the fields of digital communication and computational technologies. It provides a premier platform for academia, industry professionals, and researchers from across the globe to exchange ideas, share knowledge, and foster partnership that will shape the future of these transformative fields. So allow me to present the key features and statistics of ICDCC 2024. So this is organized in collaboration with IEEE, ensuring adherence to the highest technical standards. And our keynote speakers were Professor Richard Socher, founder of U.com and Stanford University, USA, Mr. Jeshwant, Team Gemini, Google, USA, Dr. Abhay Dalsania, Principal Director, LTIM Entry, USA, Mr. Lalit Yagnik, CDO, Global Digital Transformative Solutions, Australia, Professor Ramvilas Pachori, IIT Indore, and Professor Sujit, Professor Tanmay from IISER Bhopal. So our chief guest were Professor Govardhan Das, Director, IISER Bhopal, and the guest of honor was Mr. Amitabh Tiwari, Regional Head TCS Indore. And in this conference, we have received 927 papers from various domains, in which like 165 papers accepted, representing an acceptance rate of 17.79%. The mean plagiarism score was 16.79, that is actually reflecting the high originality. And the papers were reviewed by 2020 international experts from the globally reputed organizations like Meta, Google, Amazon, and other prestigious organizations. So I extend my heartfelt gratitude to the management of VIT, our Vice Chancellor, Registrar Sir, Executive Dean Sir, and our organizing team, and tireless volunteers for their efforts in making this event a reality. Special thanks to the authors, reviewers, and distinguished speakers whose invaluable contributions have elevated the quality of this conference. So thank you very much.
Thank you, ma'am. Now, I would like to call our Executive Dean, Dr. S. Kundaran, to share some views about the conference. Thank you. So respect date Skype, organizing chats, Dr. Hebraj and Dr. Sikshaka, and other organizing group, reviewers and participants and students and professors. I am delighted to join this session. Really, I haven't prepared anything for this speech, but I have a small message with you all. So basically, the conference is a one venue. So where we will bring, actually, we will be bringing a different thought process into a single area and will culminate with a lot of colors going out together. So I saw this meticulous planning which is happening in this last 2 days, the entire event plans. It's really a good thing. And you have set up the new stage and new heights for the data science. And congratulations for all the entire team. So who have supported and who have bring this stage to VIT Bhopal at present today. But as usual, this conference success is not stop with only the 2 days of conference proceedings. It has to go in a multiple way. So I hope many of you are connected with various proposals and various collaborative venues and everything to take it further and bring it to the shapes. So that is really the success which we need to gather it, because if you want to talk about data sets, we require a years to year group for okay. So probably I'm sure because the speakers list which is taken for this conference is beautiful. Like it has a good blending of various experts and various subject lines. So and that's the only message. So definitely we can talk well, and you are working hard. So best wishes. Now, I will draw the curtains on this moment, and the memorable event. I invite Dr. Himraj Shobharam Lamkoche to deliver a vote of thanks.
भैया
Good afternoon. Thank you for that, and let me thanks to God for giving strength for last 2 days. It was a very hectic schedule, and let me give you a very, I'll give you a journey that how this started, and based on that. It was started in the month of June and July, when Dr. Harshavardhan told me that you have to do conference in collaboration with Virendra Singh Kushwaha sir. So it was a very short span of time because we have to send and update the flyers, and there are many things which comes in order to execute a conference. So both of us, which means Dr. Virendra Kushwaha and me, and along with special mention to Dr. Siddharth Singh Chauhan. So we sit together every single day, right from August 1 till date, even on Saturday and Sunday, to discuss the thing that how we can make the thing possible on 29th and 30th of November. It was an extremely well planned planning alongside with Dr. Siddharth Singh Chauhan and alongside with Dr. Anju Madam, because they have really been supported. Similarly, I would like to also thank Dr. Harshvardhanan sir for providing a lot of inputs, lot of directions, because the direction is required, because someone says that a good leader makes you believe in them, but the great leader makes you believe in you. That's what I got the guidance, that let us move ahead, let us take a decision and bring some good speakers, sessions, as well as guests for this particular conference. Then I approached to one of the most fascinating personality in the world, which is none other than Richard Saucher, who is having around 2 lakh citations till day in a very short span of time. So this is the best thing what we can do in a very short span of time. Initially, he agreed to come offline, but due to some certain schedule in USA as well as Thanksgiving week which is going on, so he managed to provide an online session, and it was one of the most fruitful session and the key highlight of this conference. Second thing, I would like to thank Dr. Punkudaran sir, because whenever I approach to sir, sir always have that strength in words, that particularly that you can do it, and my support is always there, and you should do it. Every single time when I approach to sir, it was like the same word only, that let us do whatever best we can do for the university, for the students, and for brand building of particularly Vellore Institute of Technology, VIT Bhopal University. So alongside, I would also like to thank my core committee members. I will take the name one by one. I'll start with the publication chair. I thank Dr. Siddharth Singh Chauhan for providing tireless effort with a lot of this and that, but I would really like to thank Dr. Siddharth Singh Chauhan. Similarly, I would also like to thank the members who are involved with publication chair, Dr. Anju, then again Dr. Virendra Singh Kushwaha, Dr. Subhash Patel, Dr. Kumar Swamy sir, Dr. Razak sir, Dr. Munishwaran sir, especially for providing needful financial help on time. So thank you sir for that. Similarly, I would also like to thank Dr. Swagat for there are a lot of if and buts are there in order to finalize what are the content needs to be there in banner, what are the content needs to be there in your invitation, what are the content needs to be there in so many official documents. So Dr. Swagat is one of the most key element, or not element, but one of the most important person in this conference, who provide needful changes and help throughout, alongside with Dr. Venkat Padi sir also. Similarly, I would also like to thank Dr. Rajit Nair as well as Shiv Anjali Madam for providing needful assistance in publicizing the event globally. Dr. Rajit sir have contributed a valuable addition in pushing the research papers flyer to countries like Gulf, Denmark, Middle East, and many other things. I would also like to thank Devraju sir for providing needful assistance whenever it is needed, and the most important thanks to Dr. Sarvanan S as well as Sarvanan D for bearing me a lot. I know that I have been sometime into strict mode that you have to do it, and at that I would like to just apologize if I have did any kind of mistake. See, we are learning and we are growing, and I always believe that always be a part of a growing tree, not the grown tree. So that's what, and once again, I would like to thank management. I would like to thank VC sir for providing needful support at VIT campus Bhopal. And also I would like, one person is missing, there are a couple of persons missing. I would like to thank Tripti Madam and Dr. Lakshmi D and all my session chairs who have contributed a lot in the last 2 days, because they are the one who have did the presentation right from morning to afternoon. And let me tell you, there are 2 days. In that 2 days, we have completed 165 presentation. So this was a very phenomenal achievement, because in day one there are 80 presentation and in day two there are 85 presentation. In the first half it was 40 presentation which are running in parallel track. There are 5 parallel tracks, and the overall responsibility of leading and maintaining the track is of Saravanan D sir. So Saravanan D sir, I would like to thank you especially for providing the needful help and support on time. I would also like to thank Dr. Jitendra Parmar and Dr. Rajneesh Patel for providing assistance throughout whenever it is required. And one more person who is not there today, Dr. Ajay Sharma, for providing social media support throughout. If I have missed any single person, please bear me. And the last and foremost thank is to all my dear students who are here tirelessly. They are doing a lot of work, including the photography club. Dr. Mayan, wherever you are listening, I'm thankful to you also. Please convey my message to Dr. Mayan also. And Pavitra Madam, I would also like to thank you, because you have did a lot of hidden works where means you are not highlighted actually because you are just a committee member, but you are the one who actually contributed a lot. So at the end, I would like to thank every single person who are involved directly or indirectly into this conference and make this event a very successful event. Thank you. Thanks a lot and Jai Hind.
Thank you so much, sir, for sharing the journey on ICDC 2024 with all of us. And thank you for making this event come true. We had a lot of good memories and we learned a lot. Last but not the least, to make a statement and end our today's valedictory event as well, I would like to call our Dean SCAI, Dr. Harshvardhanan, to end this on a great note.
Good afternoon, all of you. I think I can start with the names which have been not mentioned. People who have been working in the background. So let me start mentioning the name from Mr. Dinesh, who is from our accounts department. So whenever we approached him for various Dinesh and Purnima, so for various reasons we have to talk to them. Whenever we approach them, they were very helpful. And even now, after conducting a conference, we have to settle the accounts. So hopefully, Dinesh and Purnima, they are the one who has supported this whole in how we can handle the budget, how we can take care of the expenditures. So they have been guiding us. So I am thankful to them. So next is Mr. Murugan, who is working in our office, who has been helping us in organizing various things, starting from arranging the menus, talking to the food caterers. There are various things that will be supported. So I would like to thank him. Then Dr. Vishnuvardhan. In fact, as Debraj was telling, the planning for this conference has started 2 years before. Okay. So that time I was not dean, I was program chair. I had this topic in my mind, and it is actually the conference title is not data computation. Many of them have said it is mentioned it in a different way. Actually, it is data computation and communication. Okay, so I was trying to mention this in the inaugural function. So for some reason, I don't want to mention that, but now I'm telling you, the conference is about data science and computational science. There is something called as computational science. Okay, so I started a program integrated tech here, computational science MIP. Some of you are from MIP course, so it is based on that. So the title is data computation and communication. So the whole idea started 2 years before. When I was program chair, then I was promoted to division head. Now I'm dean. So I thought that if not, when I can conduct this conference. So I started this conference. Actually, Vishnuvardhan, I would like to thank Vishnuvardhan. Vishnuvardhan is the one who has started this company with ITP. Then for some reason, he became overall in charge for the construction, so he could not continue. So I requested Devraj, and Devraj has given full support to me. I'm very happy with the Devraj execution, the way he executed the whole conference, his planning, how he planned for everything, and his team, Mr. Siddharth Singh Chauhan, then Anji Shukla. So they planned everything very nicely. I have never expected such a kind of organizing capacity from this team. So I am a person, I have some administrative experience. So I used to do like this. So when I spend lot of time in choosing the team. Once if I choose the team, I leave it to the team. It is up to the team. Whether it is going to be good or bad, it is up to the team. I won't interfere. So I'm very happy that this team has delivered more than what I have expected. So we know our limitations here. Within that limitations, they have done a lot of them. Congratulations for you. So I would like to conduct many such events in future, conferences, symposiums, and workshops. All these are possible only with the faculty support. And I have to mention the students' contribution also. The students are those who are here, the volunteers. They have done a very good, beautiful, and wonderful job. Thank you very much. Other than that, I think I have mentioned every other name which has been. Maybe I might have also left out some names. But anyway, thank you all for joining with me. And we hopefully will have many such workshops and events to be organized in the School of Computing Science and Engineering and Artificial Intelligence. Thank you very much.
That's aggregates.
Thank you, sir, for acknowledging all the efforts and contributions that make this event possible. Now, I would like to request all the ladies and gentlemen to rise up. Forward. Now it's time for the distribution of certificates. The first name, Aditya Saxena. Sawan Singh. Abhinav Jha. Himanshi. Congratulations. Hiram Khan. Ashwin Pillai. Achi Sharma. Ritika Jain. Palak Shah. Animesh Gone. Vedant Singh Kushwaha. Aditya. Teen Khan. Hardhan Singh, Vaishnavi Parashar, Tanishq Tiwari, Amritasha Gupta, Pavi, Pranav Bharadwaj. Anay Soni, Ayushi Fish, Dhani Malana, Nishita Vandu, Richa Sharma, Anshika Deborah, Palak Gupta, Raman Awasthi, Mayur Karanjia, Amritasha, so now I request faculty members, one by one I'll call the name, please come. Dr. Azad. Thank you. Dr. Muniswaran. Dr. Virendra Singh Kushwaha. Dr. Subhash Chandra Patel. Dr. Kumar Swamy. Sarvana D. Followed with Dr. Sarvana S. Dr. Maniman. Dr. Devaraju.
ये खोल दो।
डॉक्टर तृप्ति शर्मा, डॉक्टर लक्ष्मी डी, डॉक्टर पवित्रा मैम. There are bigger hands to say desires for them. How many of you are benefited out of the private participation? Thank you, thank you. Dr. Periya Navin. Thank you, Dr. Prabhu Gana. Honorable Bridget Mahan. Dr. Jitendra Parmar. Should I take? Yes. Dr. Rakesh Srivastava, Dr. Rudra Kalyan Nayak, Dr. Swagat. Thank you, sir. Dr. Rajneesh Patel. Clap your hands. Rajneesh. Come here. Dr. Anju Shukla. Thank you, sir. Dr. Siddharth Singh Chauhan. Please round of applause.
Lapit Hindrat, sir.
Dr. Harshavardhan sir. Again, once again. Now, Dr. Polnandaran sir. Now, before completing the program, I would request everyone to please rise up for the national anthem. Both photos, okay. We'll take a photograph. Okay. I request volunteers and faculty to let's have a last, not last, but let's have a group photo.
बंद कर दूं भैया
Please be on the stage. Faculty members, please be on the stage. Students can occupy the remaining areas of the stage.
क्या नहीं मैं भी करती रही
No.
वही कैसे चल रहा है फ्रीज हो गया अब
देख लो वरना
सदका भैया भैया इसका चार्जर डिस्कनेक्ट कर दिया 3 पॉइंट लगभग
तुम्हें वेट करो